months in a session, we're all meeting here. Last month we did not have a meetup actually. And there are two things kind of special about this. Not special actually. One, our main host is not here, so I'm kind of stepping into his shoes. So Subin, I know you're watching us. We wish you a speedy recovery. And second thing is, in the venue. So we've been graciously provided Tapasya Hall by the CEO of Infopark, Sushank sir. So on behalf of you all, I really give him a grateful thank you. So without much delay, let me welcome the first speaker of today, Advait Narayan. Advait's second talk. Last time when he talked, he was talking about his Raspberry Pi setup. And he is an intern at IBM, and he tells me that he is also a home labbing enthusiast. So Advait will be talking about an agentic visualization software, which is also his hackathon project, and now he's kind of keeping it as his hobby project. So welcome, Advait.
Hello. Thank you, Ria. Thank you. Hello, everybody. My name is Advait. So let's start the presentation. Okay. Ria, hello. Audible?
I think the volume is gone, right? Yeah, that was gone.
I hope I'm audible to everybody. Yeah. So anybody has a problem with Malayalam, doesn't understand Malayalam?
We don't have. We have to do a little bit.
Yeah, it's fine. I'll continue in English. So hi everybody. My name is Advait Narayan. I am currently working as an intern at IBM in the What's Next data product. So yeah, this is a small hackathon project. So this is not, I wouldn't say this is more like a talk. This is like me sharing my project experience with you guys. And yeah, so just to get started, DataLens is a small agentic visualization software that me and my friends tried to hack together at the internal hackathon that we had. So without further ado, let's get into the story. So first of all, the background. So I am, again, a very exploratory guy, you could say. I try to find new things, and I like to explore a lot of things. So recently, again, just to give you a bit more introduction about myself, I am part of the Kerala Rustaceans group, if you guys are familiar. I'm part of the Kerala Rustaceans group, and so at the last meetup that we had, I got to know about something called as flight and arrow. So arrow, parquet, format, flight, these are all protocols, you could say, by Apache that help in data delivery and processing of data. And especially we had a small discussion on SIMD, single instruction multiple data is what I think the full form is. Yeah. So yeah, that's how I'll just go through. So as you can see, there's a big chart here that does not represent anything. But you, for a second, thought that this was important and I was going to say some statistical value. But that's what charts do. That's the importance of visualizations. So whatever presentation or whatever date or idea that you want to convey, you can always have a better connect with the audience or a better reach with the audience if you can visualize it. Right? If I say okay, just to give you an obscure reference, how many of you guys have watched JJK? Jujutsu Kaisen? It's an anime, it's a Japanese cartoon. Don't throw stones at me, it's not cartoon, it's anime, I know, but dumbing it down. Okay, so Jujutsu Kaisen is a Japanese anime, and if I were to say you, if I were to explain it to you that there is a very high power like chi oriented guy with who can bend space time, has can open dimensions and stuff, it won't be that interesting compared to how you watch it yourself. So again, visualizations and things that you see make you interact in make the audience that you want to show your content more involved and oh sorry, do we need me on the screen? So yeah, so that's what charts do. So coming to our idea, we wanted to make a visualization tool, and in the age of AI, why not make it agentic? Is what our thought process was, and that was one of the requirements that we were also given at the hackathon. So it's like killing 3 birds in 1 stone, but we don't know how to throw stones. So what did we try to do? So the objective that we were trying to achieve was to make a enterprise grade, scalable and flexible application. So what do these keywords mean? Enterprise meaning for the past 4 years in my BTech computer science that I've been studying, I have not really worked on a project that I could say is reliable. If you guys know, you might also know that most of our projects that we finish late night just before like drinking 5 cans of Red Bull and maybe a few shots of coffee often ends up working because of duct tape. So you can't really say that a software is enterprise grade or reliable unless it is rock solid, you could say. So since I am just going into the corporate world, exploring what's happening there, I wanted to make something from my side as well on how, from what I've learned so far. So I've been an intern at IBM for 1 year, and from what I've seen at that company and what I've learned from there, I've tried to make some software that is reliable. So that's the first thing. That's why I tried to make it enterprise grade. You could say it's not enterprise grade as of now, but that's what I tried to make. And this is mostly like a learning experience, and that's what I did. So it's not like a talk, but it's a talk. So the next thing I want to do is make something scalable. So again, if you are familiar with late night projects like BTech projects or anything, the most that you've done for scalability is try to host it in Docker. Other than that, you just skip it. It's like so on the day of presentation, you just do npm run dev and then hope it works. Then node index.js or something, and then try to get the project working. And if it does not work, you try. Okay, it is working actually. I can show you with hopscotch or yeah, I won't say the other competitors. But yeah, so again, that's something I wanted to tackle. I wanted to try to make a scalable product, and again, flexibility is also one thing that is very valued in enterprise, because most of the customers or most of the people who are trying to have these softwares in their own company will have their own requirements. They may require some resources that are different from other companies. So that's why I also wanted to make it flexible in the sense companies can take it and customize it in their own way. So, and finally open source. You know, I am here. Yeah. So just to show you what I've done, there is no working prototype as of now, but generally there is a small architecture that I'd like to share. So this is the idea or thought process behind my project. So This is like, I'll just get the easy parts out of the way. This is like a simple server with a chat interface. But diving deeper, not to seem like this guy. So this is what my friends think when I start saying technical things at my friends. Hope you guys understand what I'm saying. I really appreciate you guys here. So just getting a bit more detail into the architecture that I have planned. So it's basically like a simple CURD operation interface. Create, update, read and delete. Yes. You might know it as CRUD, but I like to call it CURD. So we have a backend server, small backend server that interacts with an LLM. Right. So the main idea behind this is being agentic is that it is able to figure out visualizations or give you suggestions on how to make visualizations in a very easy manner. So what, let me see if I have the visualizations that I had made. Yeah. Let me see if this works. I hope I am not infringing on any copyrights. Sorry. So this is a small UI that I had planned. So here we have something known as an analysis studio. So that is the main concept or the main part of that what you will mostly interact with if this is a product anytime soon. So in this product, what you can do is you can create something known as a project. Right. So a project is basically a visualization set. What you could say, like basically it's like a chat prompt where you can select the datasets that you want to visualize. So how the workflow of this project works is very simple. You can select the datasets that you want, and you can type something like, okay, can you show me the best visualization for this column? Say maybe that's the CGPA or like 4 years of a student. So can you show me a thing that shows me the semester GPA of the students? So that's something that we have tried to make. So we have like a lot of projects and things, and this is like what we expect in the output. Basically like a chat box where you can put in some kind of query or natural language and it will get converted into visualizations. And it will, since the LLM is already making this visualization, it has a context on what data source it had used, and it is able to give you an explanation as well. So the main point of creating such a software would be for exploratory data. If there is already data existing, there is most likely a chance that there is already something like a dashboard on like maybe Grafana or some type of tools that already exist, and there is nothing much you can do there. But say for example you are developing a new tool or making a new platform, there are many resources or metrics that are coming up that you may not be familiar what those metrics mean. So visualization in that sense will be able to help you showcase what that actually means, or makes you able to quantify what that resource consumption or something means. Right. So that's why this is here. And one more thing that we wanted to include is basically once you've actually figured out the dashboard or the visualization that you require, what we wanted to do is basically make it so that you can export these dashboards into your preferred software. So say for example, there's a proprietary software called Instana that we use at IBM. There was also open source tools like Grafana and other dashboards that you can have it's like a templating system, so you can actually put in like a JSON value into this dashboard and it will automatically show the visualizations based on the data input. Right. So in that manner, this is our idea for generally having a visualization tool. And you might be thinking, how is it like helpful? So how does it generally work? So diving a bit more deeper into how it works, what I have also tried to make is so that so if you guys have worked with LLMs, you might be familiar that LLMs don't do well with numbers. Anybody who's worked with LLMs and numbers before? Yeah, you might be familiar that LLMs, when you put in an excess amount of numbers or excess amount of values or quantities, it starts breaking down and it is having a panic attack on its own. So to avoid that, what we have developed, I could say, is a small technique called as metadata generation. So again, sticking to the points of trying to make a software that is enterprise grade and flexible and everything. What we try to do is try to utilize software solutions or tools that are already in the tech space, right? So if you have worked with large data or big data, you might be familiar with something known as Spark, Apache Spark. Anybody has heard of Apache Spark or used it before? So Apache Spark is a distributed data processing engine, what you could say. It's like an SQL type of engine that helps you to get data from a distributed source. So again, that's our objective again. What we do is basically whatever type of CSV or JSON value or whatever input that you provide as a data set, we actually take that data set and convert it into a Parquet format. So that's where the, so if you guys remember, I mentioned something known as Arrow. So how many guys are familiar with what Arrow is or have heard of Arrow? Arrow, Apache Arrow. Yeah, so for the people uninitiated, I'll just give a small introduction on Arrow. I'm just learning it myself, so it may not be fully accurate. But Arrow is a columnar representation of data. Right. So you guys might be familiar with SQL, right? SQL. Right. So SQL, how do you represent data? Data is actually represented in rows. Right. We have columns for attributes and rows for data. Apache Arrow is a concept where we try to store the data not in rows but in columns. So why that is because representing data in columns has proven to reduce the amount of space or memory that it takes to represent that data. Because there are many fields or data endpoints that might reoccur in like a lossless compression. So if you guys are familiar with like pictures and JPG, PNG, you might be familiar with the term lossless compression. So lossless compression means basically we are trying to reduce the size of our data set without losing any data. That is lossless. Right. So Apache Arrow is a lossless data format. And in the environment of Apache Arrow, there are actually very interesting and fun tools. I wouldn't say fun, but for an interested person in data or things, it might be fun. But generally, there are very interesting tools like Apache Arrow Flight. That's something else that caught my eye. So, can anybody guess what Apache Arrow Flight might be? Not Air India, but anybody has a guess on what Apache Arrow Flight will be? Looking at the visualization. Transfer, right? So transferring data from the back end to the front end. So the reason for me choosing Apache Arrow, so Apache Arrow, to give you clarity, is basically like a transfer protocol. It's a protocol based on RPC. So you might be familiar with RPC, right? gRPC, remote procedure call. So Apache Arrow is a protocol based on top of RPC that helps you transfer these arrow representations in memory from one device to a client or a server on the other side. Right. So what is the benefit with this? Since the product that you're working, the product that I was trying to develop is dealing with a lot of data. Right. So there may be instances where an enterprise customer, so especially my use case was to actually figure out the logging and so try to make sense of what output or metrics that you're receiving from your application, right? And if you guys have worked with applications like that, anybody heard of Prometheus or used Prometheus before? So yeah, just to give you again an understanding of what Prometheus is basically a database. It's a time series database that stores the information about your application. Right. So what information does it store about your application? So say for example you are making an application in Rust. Okay. So as usual, you are making an application in Rust. What happens is when you try to call something or make a variable, what actually happens? What happens when you are actually trying to make a variable? Can anybody say what happens when you are actually making variable? It's a very simple thing that I am asking. Memory allocation, right? it takes up some amount of memory from your computer's system resources, right? So that is actually something that you can monitor, and that's what Prometheus allows you to do, right? So as I mentioned, why visualization is such important, or why tools like Grafana or Prometheus are such important tools in all of the industry is because we are able to see how much memory utilization we are having, right? Using these tools, we are able to visualize how much. So you might be familiar if you guys have maybe Open Task Manager or the alternatives, that you can see that it actually shows you the CPU utilization, right? It shows you the amount of CPU that's using. So you can easily identify what resources are consuming a lot of power or a lot of resources. So that's why this is actually required. So coming back to the reason why I chose flight is because usually these metrics are accounted for per second, right? So if you just consider that there are 60 seconds in a minute, 60 into 60 seconds in an hour, 60 into 60 into 24 seconds in a day, 60 into 60 into, you get the point, right? So there are that many endpoints and that many data points that it might be a bottleneck sending it through HTTP. So that is why since we already have converted into a format like Arrow, which is a very efficient data structure, we are getting benefits of the transport between two clients, and also the representation, the data representation, memory consumption on both the client side and the front end side is low. Right. So imagine if I was to pump like 10 GB of data into my front end HTTP like client server. Like, do you think React or any framework will be able to just handle raw 10 GB data on your browser? Probably not. So it might end up slowing your system so much that you think you need to buy a new laptop. So that's why I use Apache Arrow. And again, that's generally how this project is architectured in general. Right. So yeah, and coming back to the other components that I missed out, and the main component that is LLM. Right. So what we're actually trying to do is, again, I think I skipped that part somewhere, but LLMs are not good with numbers. Right. LLMs are not good with numbers. So what I try to do is basically make something called as metadata. Right. So what does metadata do in general file systems, or what does it do generally, metadata? It helps you identify things, or you can see. So if you look at the metadata of something, you can see if it's an image, or is it something, is it a video. You can identify what type of data it is, or what type of substance that is inside this file, right? So similarly, what we try to do is basically make use of LLMs to figure out what metadata is considered inside the data set, right? So say for example, if I send it this set of logs to my Prometheus or backend server, it will be able to identify that, okay, I am getting this column as this data. Say for example, CPU utilization is usually a floating point number, right? So that is information that is actually helpful for the LLM. Would you agree? Because if I am to ask somebody, so if I call somebody here and ask you, okay, I have a list of floating point numbers, and what would be the best way? So floating point numbers over time. Okay, so I have floating point numbers over time. What would you think is the best way to represent that floating point numbers? Like, how can I infer? So just like, you know the difference between data and information, right? Data is basically a set of numbers inside a computer. Information or knowledge is basically what you get from that data, right? What you infer from that, what you understand from that data is basically knowledge. So since LLMs are glorified autocorrect machines, it does not have the capability to actually understand what that data means, and it does not know what to interpret from that data. It's up to us, right? But to give the LLM at least a fighting chance, rather than just spilling a lot of numbers in space and say demanding its answer, what we are trying to do is basically saying, okay, we have a data set that has this column which has these values. The values range from a floating point number of 000 to a floating point number of 100.00. Right. So that gives the LLM a lot more context without handling a lot of numbers. Right. So in that manner, the LLM is able to think clearly. Okay. This is a floating point number, and as for my training goes, it's probably a bar graph or a line graph that would best suitably represent a set of floating point numbers. Right? You guys would agree, right? Like a floating line graph that goes up or down is a good representation of floating point numbers over time. Right? So that's something the LLM can then predict or suggest for you to make a graph of. Right? And then, yeah. So again, just to have a detailed idea on the components, the server that we did for the hackathon was written in Python, but obviously we'll be writing it into Rust. Yeah, we'll be porting it into rewrite in Rust. And yeah, again, as we mentioned, LLM. So if you guys are familiar, there are a lot of varieties of LLMs that are coming up. And one of the important things that was very helpful for us are two types of LLMs. So one is the instruct model of LLMs. How many guys have heard of instruct models of LLMs? Right. So for the guys who don't know, LLMs are very naughty, you could say. Not in any other sense, but they don't usually respond back in the way that we say it. So this is Raycast. So if you guys are not familiar and if you guys are using a Mac, please use this software. It's open source.
Raycast is not open source.
Oh, I think plugins are open source.
Yeah.
Ecosystem is open source, so I so I have it connected to Olama, my local AI inference thing. So I'll just ask something in this, right? So I just asked it what is Kochi FOSS. Yeah, so Kochi FOSS is a community-led initiative promoting open software and hardware in Kochi and India. Right. So I think that is something that we all agree on. But what if I ask it to do something else? I don't know what that is. So if you guys can't read, I'll just read it out to you as much as I can. Kochi FOSS Porteco Comunicaro Promueve Software en Hardware. I don't know.
Spanish or
Spanish? I don't think it's Spanish. I don't know. This is not what I expected to do. Right. I asked it something else, but it gave me something else. So LLMs are not reliable, is what you would say.
What did you ask?
I forgot. Can you write this out as text? What I meant was basically like a bullet points or something. But yeah, again, I didn't prompt it properly, and that is also one more problem with LLMs. I obviously did that to show you guys. So the problem with LLMs is that if you are not prompting it correctly, and even if you prompt it correctly, there are chances or possibilities that something like this comes up. Okay, so in the hopes and dreams of making an enterprise software myself, this is not at all reliable and not at all required for my software. So that's where instruct models come in. So instruct models are LLMs that are tuned and trained to follow instructions. Right. So these are like very obedient dogs, or you could say, that follow the instructions, and there are many syntaxes and styles of prompting that you can do to properly get the output as instructed from the LLM. Right. So that increases reliability and that increases the safety, you could say, of this program. So that's where LLMs have also been a good part. And the second part of the LLM, the second type of LLM that has been very helpful for us, which is the exact opposite of instruct models, are reasoning models. So how many of you guys have used reasoning models? I'm pretty sure the thinking something like, so if you use ChatGPT recently, it will be like thinking and spits out the garbage. So that's the exact opposite of instruct models, that I would say. But that's also helpful in some reasons, because since we are processing a lot of information and we are trying to figure out, so basically it's like the software is like, okay, LLM, so the software is actually asking the LLM of what type of data or what type of visualization I should use for my data, right? So if I just put this metadata in and ask the LLM, okay, hey LLM, can you say what type of visualization would be good for this? So that's where the reasoning LLMs are very good at, was what we have figured. So how is that different? So reasoning LLMs have an internal thinking mechanism which is completely BS, but it is like I appreciate LLM, but yeah. So the thinking mechanism inside the reasoning models helps it to run through the prompt or run through the output what it has said again and again and again, right? It's able to reiterate on itself, and it's able to kind of basically think, right? So whatever I'm saying here out loud is something that's output from my brain, and I'm also thinking about what I'm saying right now, hopefully. But yeah, that's something, a feature. So reasoning models is something like what LLMs have to similar for me to talking here, right? So that's how the importance of LLMs are also. And then yeah, again I try to use S3 compatible storage. So if you guys are familiar with Min.io, anybody heard of Min.io? S3. Yeah, anybody heard of Amazon S3? Yeah, so Amazon S3 is a very widely used object storage that is very good. So cheap and good actually. So Min.io is actually a self-hostable, I believe. Oh, okay. So again, it's open source. So thank you for reference. But yeah, so that's why I use S3. So because, and again, since this is S3 compatible, any object storage that is S3 compatible will automatically work with this. That helps me get the points of flexibility and extensibility. So and yeah, Apache Spark. And Apache Spark finally is there to help us collect all the data from all the places everywhere in a distributed manner. So yeah, those are the components for my software, and I don't want to bore you with the software like project structure. As of now, it's a mono repo, and I plan to deploy it using Docker, Kubernetes, and Nix. Nix configuration, Nix mention. But yeah, sadly somebody's not. Yeah. So this is generally the project structure that I'm planning, and why one of the main reasons why I came here, that is my action plan, is I want you to contribute to this. I will see. Again, this is my hobby. If you guys have time or you want to learn something, I will be also happy to learn it with you guys. And since that, I'll be happy if you guys contribute. So that's generally it. And we can together watch the songs grow up. And finally, yeah, this is the repo. Feel free to make any PRs or any issues or even clone it or do whatever. I didn't have a license, I'll add it soon. So that is the end of my talk. I'm happy to.
So you have the Spark jobs pulling data from the database. Yes. So do you only pull a segment of the data, or do you pull the data table for the data? How do you manage context and stuff?
Yeah. So the question, I just say the question again. So the question is basically how will I so as I mentioned earlier, we have a data store, S3 compatible data store somewhere with a lot of data. And I have something called as Spark, which is a query engine that will basically go to all these data sources and get this data and send it to my front-end application. Right. So the question that was asked is basically, how can I inform the LLM, or how does the LLM actually get involved in this data selection process, right? I don't want the entire data set of all the data and all the columns. I don't actually need that for visualization, right? Mostly you might need two columns, one in the x-axis and one in the y-axis, right? Or maybe if it's a pie chart, it's even simpler. So in that situation, what I actually tried to do, as of now, we have an implementation in Python, pandas, data frames. But what I tried to do is basically I've asked the LLM to also return a query. Right.
Okay.
So it's basically, so if you guys are familiar, that was something that was trending in Twitter some time ago. Basically, natural language to SQL query or natural language to some type of query. Right. So since it has evolved a lot and it has gotten a lot of better recently, what I've done is basically ask the LLM to also generate. So if it says bar graph, what I've asked it to do is also, okay, bar graph and what data. So the response for what data will be in the type of a query that I can run on the Spark, or maybe as of now I have done it in Pandas data frames, and it will just apply that data and try to get that, and we'll substitute it with the boilerplate configuration file. So for the front end, I'm actually using something known as chart.js. Front end people might know about chart.js. So chart.js actually requires a JSON configuration to be put inside with the data that it can actually visualize it. So what I'm actually doing is I'm actually asking the LLM to give me a template of that config file, and where the data should be, I'm running this query and just swapping the data and then sending it using Flight to the front end. I have not done this yet, but this is what I have planned.
I want you guys to learn.
Yeah. Yes. So anything else that you would like to ask? Any alternatives that you'd like to suggest? Or
Plotting data, that's it. And it chooses a visualization. You're not even telling it what type of visualization, just provide me the best visualization.
Yeah. What do you think is the best visualization? Just show me, is what this tool is. And for the lazy people out there, I even have a smart button.
Smart button.
Yeah, so you can see in the bottom right corner there's the do what you want. Just click that button, it will try to give you some visualizations on its own. But else you can actually
Visualize your dreams.
designer versus developer moments. And yeah, again, the dashboard also.
This is IBM URL.
Yes, Carbon.
Yeah, carbon.
Yeah. So again,
I think hackathon.
yeah.
So you were supposed to use it.
Yeah, it was actually an internal hackathon, we didn't get selected, so I am here.
Okay.
So yeah, again, we tried to provide a lot of cataloging options so that it's easy to manage a lot of data. So I didn't actually show you guys this. So there is something known as the data processor part as well. So data processor is accompanying the analysis studio. It's basically like a platform where you can manage your data sets because usually data sets like these will be very large and expensive. You can actually upload your data sets, and we are actually again making use of instruct models to actually generate the metadata for this data as well. So in that sense, it will actually try to figure out what this data is. With the help of this metadata, we are able to actually have a better output compared to just passing a bunch of data and asking the LLM to make a visualization. So metadata, and also there is a project by Microsoft called yeah. So if you guys are familiar, this is actually a very good read, but this is an open source. Yeah, project that is basically automatic generations of visualizations by LLMs. The approach used by Microsoft and us is a bit different. What they're trying to do is basically try to create Python scripts that actually make the visualizations and send it to the front end, but remote code execution, no. So yeah, this was actually a requirement for the hackathon, but we blatantly ignored it. So yeah, this is actually a very good, interesting project. If you like to check it out, this is also something that we used to reference. So the metadata idea and everything was inspired from this project. And yeah, so thank you.
Do you have any examples of the visualizations you created?
We didn't create.
That you hope to create?
Yeah. I can actually hopefully show
All those were like,
yeah, We actually as you saw in the second slide, we were all very sleepy and tired and mentally overtrained because we were not able to complete the project. But this is what we got to show, like till here we did. So this is basically the data, the data station that I mentioned earlier, like a small question. So I don't think Minayo is up. Yeah, okay. I believe Minayo is also up now. So if you just, there's a dummy CSV file. It has a small data set that is basically name, if they passed or not, and the CGP of a lot of students. Right. So I just open this data set, and what it does is basically it converts the CSV into Parquet. So again, Parquet is a ecosystem member of Arrow. And Parquet is the in-file representation of Arrow database, like columnar representation of data on a file. And why we did Parquet is because easier to convert Parquet to Arrow and vice versa conversions as well. And what we did is, so if you just see, there's a data set showing inside. So this is the Parquet file, and what we're trying to do is basically, so if you want, this file A4948, right? So if I do analysis, what it does is basically it sends this data, examples of this data to the LLM, and it is able to generate a markdown document. So let's just see what the markdown document has. So the markdown document has the name, and it's a dummy data for student information, string student, and like some examples of this name of student, and student pass status equal to overflow. So this is basically a metadata that is helpful for the LLM to generate in future. So if you just pass it to the next reasoning LLM, what it can do is it can actually base its results of reasoning from this file. It can use this metadata. Okay. Since the pass variable is actually a Boolean, the best way to do this will be a pie chart, right? Boolean, there are only two values. There is nothing else dependent on it. What you can do is easily make a pie chart with this, and that's what we'll be trying to implement. Right? So this is the yeah.
So the min max those values, right? How are they calculated? Do you have like formulas that
No, trust the LLM. Again, that is also something we could do. That is actually like get the min max, average mean, like lot of random statistics from actually processing the data. Since you already have Spark and all the object storage connected, it will be very easy for us to actually do that in efficient manner as well. So that's something also we can integrate. Yeah. So this is there should be a table here. We were reaching checkpoint 3, so I didn't have any. So with that, so thank you everybody, and thank you for having.
Thank you, Advait, and I really hope we get new contributors. Okay, everyone. Next up, we have Andrew. Andrew doesn't need any introduction. He's currently the CTO of Hopscotch, and he'll be talking about Elixir and Beam and how they are used in building web services. So, welcome, Andrew.
Hello everyone. Hello everyone. So this Aditya. He's vendor. Okay, good. Okay, so I give you talk about D-Minetics. So I'm not. So they are at the Kochi FOSS Meetup. Who is here for the Kochi FOSS Meetup for the first time? Like, first time. Oh, okay. We have a lot of first time talks. Awesome. Okay. So if you guys are not familiar with me, I am Andrew. I am the CTO at Hopscotch. Hopscotch is this API testing platform thing in open source. Open source. Yes. Yeah. So I'm the CTO there, and we don't use Elixir or Beam in our code base yet. So I don't think we will. But generally, this is regarding some explorations I did like for the past year. So it's a lot of things around that journey. So one thing again, especially with my talks, because we have a lot of new people here, I like to put a little bit of humor. So I will hurt your sensibilities if you are in the following communities for this talk. If you have any appreciation of JavaScript, I will destroy that. Same goes for the Ruby community. Thankfully, the Ruby community is not here. Subin is not here. Vijay is not here. Vijay Vadalin was scarier because he is like Kaladi and stuff. None of the Ruby folks are there, so yay. I mean, just that's not my actual thing. I think those things are cool. I write JavaScript for a living. So it's just all for like comedic effect. So do understand that when I say something like JavaScript sucks, it is actually a slide. So don't take it as like I actually mean JavaScript sucks. Yeah. Okay, so the goals of the talk. This will be a classic Andrew rant about complexity in software systems. Because I will be making fun of the Rails community and the Ruby community, DHH question mark. I don't know if everyone is familiar with DHH, I think. But DHH, David Heinemeier Hansen, bro, is a part-time Rails Elixir part-time CTO of Basecamp, and also created Ruby on Rails. Yeah, not getting murdered by Ruby, Kerala Ruby community. I'm pretty sure I won't die during the talk, but after that I don't know. And then other important question that Kiran asked me is Beam and Alien to Chota Beam? Not exactly. Alien means like brother-in-law. And also another point is like teach you Elixir, not to teach you Elixir syntax. Like this is not like a tutorial or like the goal is not to kind of get you into it. The more is like I want to talk about certain like parts of like Elixir. So. Another thing, especially who are folks who are Malayalis here, might know some CBSE student voice note, student group voice note relating to something Elixir that I won't be talking about here because not part of code of conduct. We are not going to talk about that during the talk and maybe probably also after the talk. Yes, so that's basically what that is about. Cool. So what is Beam? It is not short-term Beam. Of course, there's no relation to that. Even the spelling is different. I think the full form of it is more like Bogdan's airline abstraction or something. And it was basically a VM designed for Erlang. So Erlang is a programming language at Ericsson, so the telecommunications company. If you know Sony Ericsson, I don't know if anyone boomers are there. Boomers are there, then you will know Sony Ericsson. If you are more older, like my dad, he had an Ericsson phone before the whole Sony Ericsson merger was there. It's pretty cool. He had a full, the full like the belt and all stuff for the phone. It's like very cool. It was there in my dad's and mom's marriage photos and stuff. He actually had the belt thingy. Okay, so. Beam is part of, and it's basically the core, the heart of the Erlang Open Telecom platform. So, Ericsson has to make all of these telecommunication stuff, and they have this, they created this programming language called Erlang, and there is the VM for it, there is Beam. There used to be another called Jam. The Beam is like a successor to that. And what OTP or Open Telecom platform is like Beam plus the language plus, no, not the language, plus a set of libraries and stuff to basically power this whole thing. Although Beam is designed for Erlang, other languages can run in Beam as well. Elixir is the most popular one right now, even more than Erlang. There's a new language called Beam. It's more like if Rust and Elixir had a baby. And LFE, because of course there is always going to be a Lisp. So there are many other languages as well, but these are the main three ones. So in this talk, we are most probably going to be talking about Elixir. So if I say Elixir, whatever I say about Elixir is like a Beam feature. The only thing which is not part of Beam is basically the syntax. Cool. And to think about it in the shoes of Ericsson and why Beam and /Erlang need to be created, you have to understand that telecom engineering is tough. Right? I mean, if you're building telecommunications and stuff, you have to handle millions of concurrent connections, right? You have a lot of people, calling each other and, messages and data flowing through your systems. It needs really high uptime because all of these stuff are like very critical infrastructure, especially these days. Like, I mean, think about it, like if you have a fire, you call someone, that needs to go through the system. You are in a very life-threatening situation, somebody calls you, that goes to the system. So it's a very critical infrastructure that needs high uptime. And you need to actually have a really solid ways around errors and problems. Basically, problems are inevitable, but you need to have a very good structure to basically handle this because you don't want to cascade problems. So like one small thing somewhere down the line, just brings down the entire system. That's not good. Updates happen, new features come in, new protocols come in, and you can't have downtime for that because that means you are going to have less uptime. You have to gracefully handle load. So if a load happens, if your system is stressed, you shouldn't make it so that everyone else kind of suffers for it, or kind of the system actually kind of fails around on this thing. So it needs to handle that gracefully. And most of the cases of telecom services, especially, there's a lot of emphasis on spanning the globe these days, where like there are global services that's like Earth-scale stuff. And all of this while still having observability and issue resolution. Like it's a very dynamic and changing system with the load coming in and out, and you still need to kind of have observability and ways to kind of go around this. Which is pretty crazy. Like this is a very big engineering challenge. You have scale, you have robustness, you have distributed computing, which itself is a very complicated problem, right? And all of that is there. But if you think about it, isn't that what these days web services do? Like all of these web services are basically there. I mean, there are a lot of services even I think I cannot run without. So I would say they need uptime. I mean, think WhatsApp these days. Like it's like I won't say it is as important as like a phone call or something, but it is pretty important. And you know, those are global scale services, and they also go through the traffic and that sort of stuff. And the internet is becoming bigger day by day, and you know, all of these things are there. So this actually makes a lot more sense when you actually come into this. So like the one question which I had when I kind of researched about this was mostly around like, why isn't Beam very popular in like solving these services? So that's what I want to kind of show you. Like, okay, this is something that gets missed a lot underneath all the Pythons and the JavaScripts and the Rubies. So that's kind of the point of a talk, to basically like show like, okay, this is a really cool system because this is a very old system built in the 90s for telecoms, but now that our web services are basically the same thing, like this makes actually a lot of sense and you should maybe look into it. Right. Cool. I will kind of give you a small walkthrough through the Erlang language. I mean, not just a walkthrough. So there is this. This is actually a very interesting kind of a site. There's this site called Programming Languages as People. So you just go to Google search that. Basically, every programming language is like personified as a person, and Erlang is basically like that kind of like a mage kind of a thing, where you know, you have all of these guys, these minions behind, and Erlang basically directs them. I will get into what the minions kind of say, but what the main part of it is, this feels very medieval vibes, because Erlang is a very crafty system. It is pretty old. Again, I think the initial language release was like an 86. So it is a pretty old language. So it has kind of its thing. And so the problem with Beam and Erlang adoption, Beam adoption in web services, one was this, where it is not like, even if you look at the syntax, right, it doesn't look familiar at all. There are very less things which you feel like it's familiar to. And that actually created a bunch of friction for people to kind of like, okay, this doesn't feel familiar enough, so I'm not going to adopt it. There are still people who have adopted it, we'll get into that. But yeah, generally the gist is basically that. So, so there's this guy called Jose Valim. He is the creator of Elixir. This is from one of his YouTube videos. It's pretty nice slide. So, Jose Valim, so he used to be a Ruby on Rails core team member, and when he was kind of dealing with problems in Rails, mostly around concurrency. So Rails is not exactly pretty good at handling like what is it, like concurrency, or I think at that point when he started out, that Rails was still single-threaded. So if you have multi-core systems, it's not going to be able to use it really well. And so I think now Ruby got a little bit more better, but so he was exploring a lot of stuff. And again, he was kind of going through the same track that I was going. Basically, there's this cool thing which is Beam, and he tried out Erlang, and then he understood, like, this feels very crafty, this doesn't feel very cool. So coming from, so he thought basically, what if I could make Ruby somehow run within the Beam VM? So you can't exactly do that. The Beam VM is a little bit weird, mostly around, there are a couple of features and stuff around to kind of help for distributed computing. So it is a bit of a weird system. So he couldn't, so he made Elixir, which is like, the syntax is very Ruby-like. I would say in a lot of places it makes it better. Because it simplifies things a lot more, and you kind of work with that. So he basically wrote this Elixir. So this is like the modern age where instead of, you know, the witches and stuff, you just have an anime 10, basically, you know, drawing the Eldritch powers. So you can look at the syntax here. This looks more, if you are coming from the Ruby side of stuff, Ruby Python side of stuff, this looks very familiar. So it's basically that, but it's just literally the same code that was written before on Erlang, right? So I would say like that familiarity is like one of the main things, right? So I was talking about like Beam is able to kind of solve this telecom challenges, and so how does it do it, right? Why can Beam solve these problems and the other guys can't, right? Now the first thing you have to kind of understand is in Beam everything is sort of like a process. So you can sort of think of it as like you have like this one thread and you can kind of like run things. Now the funny thing in Beam though is when you're running Beam, it doesn't create, like one process doesn't equal to one thread. So you can create millions of them. So it is perfectly fine for like a Beam system to actually have like millions of processes. That's completely normal. That's expected. So you basically have a bunch of processes, and each process will basically kind of go into this. Processes are preempted sort of like operators. So this is literally the Elixir code to start a process. So you just literally call spawn and you give it like a function, and that when the function gets done executing, you basically the process kind of dies and goes out, right? And you can create multiple processes like that, and processes can do different set of things. And another thing processes can do is every process has a mailbox. So basically processes can send messages back and forth. So that's what I'm kind of trying to show here. So you can, this is exactly the Elixir code to do this. So you can say send, and you can get there's a process ID for every process. So you can just give it the PID of process B, and then you can send a message, and in process B you can just say receive. Receive will block until it receives a message, and then it will kind of go there. And when I say it blocks, it only blocks the process. It doesn't block the entire system. So that's what basically happens in Beam. You basically have this thing, and you basically put processes inside it based on a system. You start processes, you kill processes, processes die on their own. Basically, it's a system that evolves around that, and Beam will take care of spreading that load, scheduling it across different CPUs. So if you have a multi-core system, Beam will efficiently allocate the processes across all of the cores. So got them there with the Ruby community side. So that's it. So with this, you can kind of create like a client system architecture where like the client is one process, the system is one process, and then you can like send messages back and forth to kind of do things. So that's generally why we kind of get in Elixir and also generally in Beam languages. So I think that like the model is mostly around that. So you basically have client connection, client connection, client connection. In normal Beam systems, for example, if I'm like doing like an HTTP request, that HTTP request actually becomes like a process. And you can, when you send a message to that process, it actually gets streamed into the user basically. So exactly like that. So you model it like that. Even resources like files are processes. So you open a file, you get a file process, like a file server process, and then you can send messages to it for operations to happen on that file, which is actually pretty cool. So you can kind of see this flow kind of happening. And this is not some obscure tech, by the way. So like WhatsApp runs on Beam. WhatsApp is their backend is written in Erlang, but they are running Beam. I think they're still basically a full team. I think it's a very small team as well. I think it's like 10-20 member team. And WhatsApp is one of the cases where they have the most amazing backend in the world, but their frontend is the most horrible, crappy stuff. Like I don't know which interns are they kind of like putting into the apps. I have problems. Literally, I have a thing with my WhatsApp. I would like to demo it, but in the interest of time, I don't want to. Where I was trying to send a voice note to, a music file to a friend, and I was trying to kind of like recall it back, and I got it, and the file is there. It is a music file, and I said like say to downloads because I wanted the file on my system, and it downloaded an MP3 file as an image. Not even kidding. It's not like an unstable version of WhatsApp or something. This is the actual live production version for the macOS app. That's the situation. Discord is also the same. Discord uses Elixir. Discord also uses Rust in their. Elixir has like Beam has a very good system called NIFs, where you can do like native stuff for performance. Discord is basically Elixir plus Rust NIFs for this thing. So their backend is basically that. Remote program, change.org, all of these people use this in production right now. Even more people are there. And of course, like Elixir. So I want to kind of show you a bunch of features and also diss on the Ruby community a bit. So that's the plan. Let me see. If I figure out the keyboard shortcuts, I can do that. Okay, cool.
Font size.
Yeah, everyone can see this, right?
Yep.
Cool. So I have this very dummy repo that is probably going to be like a thing. So I'm just going to do a next release. That's just going to create a release build. And let's see. Nice. That's a lot of stuff. So I'm just going to start like as a server. So okay. Cool. By the way, guys, I am a fan of the Zen browser. If you want to try it, Zen is pretty good. Okay, cool. First thing I'm going to show you is something that the Ruby community will struggle to show you in a single computer, where I run 100,000 jobs, 100,000 requests in one machine. And if I press enter, computer, this is not the time to actually die on me. I am trying to show people stuff. Okay. Okay. This was literally working like
Ruby goats.
I think it's the Ruby gods. I think they are doing some stuff. Anyway, so let me just try this. Yeah. So you can see this is basically the number of jobs running. So my computer is not breaking as well. This is doing. So this is a very simple operation, but I'm doing like 1,000 requests. So this is like actual requests actually going into the system. You can see it's not like fully stable right now. Because again the calculation is not exactly right, and there's like differences in that. So you will see it, but it should be fine. And this is like the scheduler. This is how much the Beam scheduler is like. The load is basically on that. So I'm not going to keep this running with 100K though, because I'm going to show you some demos. And 100K means my computer will also not be fun with it. Yeah, so this is actually not a, this is a Zen bug. Okay, cool. So I'm just going to put 50 just in case. So this is actually running 50 kilohertz very easily. And I have this very basic application. And the only thing it does is basically, if I give it a number, it finds the sum of 1 to that number. That's it. Very simple application. 200, 300, 3000. I can do like a big calculation. It will take some time. Let's me do some like. It will take a bit of time to calculate that, but you can see like the scheduler is basically now maxed out, right? But the awesome thing is, even though the scheduler is maxed out, I can still do calculations. Ruby community will be dead at this point. So it is still do calculations because one thing with Beam, as I said, with the telecom thing, graceful degradation under load. If you stress the system, it will like reduce the performance for everyone else, but it won't ever block it. So if, for example, in Python, JavaScript and all, the way they kind of implement this for, if you have a CPU-bound loop, your entire event loop is just gone. Which means even if you do concurrency, unless you do separate threads, you will have problems. Rust also has the same problem because it also does concurrent. Go doesn't because Go is preemptive. And in Elixir also, and Beam also, it is preemptive. So it will use the load. Things will be generally slow, but it will never break. It will never slow down your system. But this will actually take time. Right, and this is bad. This is a bug. We shouldn't actually kind of do that. So then this is the next feature I want to kind of show you, which is basically the introspection stuff. So Beam is like a living, breathing operating system. So this is a Phoenix dashboard. This is a part of the Phoenix framework. Think of it like Rails but Elixir, and it has like a built-in dashboard. And okay, dashboard, please don't hang on me. This happens because I haven't tested out this load. Yes. It's not because the system won't work. It is because this actually is a heavy process. Okay. So you can see this. So there's this thing called reductions. You can sort by reductions. I think it is basically this. Let's see. It will eventually turn out basically which is the process which is taking up the most amount of resources. Okay. Again, I am pressing the computer trying to calculate the sum. So let's kind of put that. Okay.
And can you show the system usage right now?
Oh, you want to see the actual system usage? You would be more surprised at Apple Music considering 16. Okay. I mean,
Do you have laptop?
yeah. Oh no, it's not XP Music. That's idle.
Oh, is it?
Oh, you don't know modern development, man. That's what happens. Slack consumes like 3-4 GB, and it just shows chat messages. Okay, I'm just going to reduce the load event so that I don't mess up the system. So it's going to do the calculation, and you can see this. The processor kind of looks, and I can see basically that this reduction. So you can say reduction is sort of like how you can say how many functions are being called is somewhat similar to reductions, and you can see like this process is actually kind of like weird. This is like the number is increasing very fast. Not good. This guy is spinning up. So I can just go ahead and basically just kill the thing. So I can just take this pin. So this is the process ID that I was talking about. And if I can find my shell, and I do remote. That means I have to connect to the system which is there. So this is like Ruby people, this will seem like this is basically the same thing. But I can run Elixir code here. So I can just be like process.kill, process.exit, and then I just need to give it the PID. I have to make it so it's like this. And I'm going to brutally kill it. So this is brutal killing. That again, in Beam, you have very weird. I will say, okay, your supervisor needs to kill the children, not just kill the children, but brutally kill the children. So this is like kill 9. So this is a very common parlance. So I do that, and the system just basically kills the thing, and I will get an error here. Right? It's pretty clean. So this way, I can, if something happens, I can like live update the system. I can kind of go into that. So this is there. There are also some other issues. So for example, if I, for example, do 13, for some reason 13 crashes. By the way, I can actually put a little bit of load. Okay. 13 crashes for some reason, I don't know. And if I put 0, I have another problem. I haven't count the edge case for 0, so this is now going to infinity. Right? Again, when that happens, I don't need to do anything. I just need to go into this. This reduction count looks sus. I can be like, I can just copy paste that. And I can just, and it would save the system again. Cool. So again, just wanted to show the introspection stuff. Now the next thing, again, while all of this thing is happening, the load, you can actually see the load is actually being like stably maintained. Now I'm going to do actually something really cool. So this is actually a production build right now. So this is running on my machine, but this is a production build right now. And what I'm going to do, as you normally do, is you fix problems. So, yeah, so I'm going to be fixing production. But I'm not going to just go into the production code base and do that. No, Beam is compiled. They have a bytecode system, so you can't just go and like update that. But I'm just going to update the system. So let me just see this. Okay, so this is the calculate function thing. And yeah, so the 13 bug, I'm just going to remove. So again, this is a demo, so I have kind of did stuff like this. And I'm going to do this. And also, this calculation is kind of like, so Elixir doesn't have loops. It is functional, so you can do this. You do recursion to do like loops. And recursion is optimized because it has tailcode optimization. But you kind of do this. But we can just go into like 10 standard maths and replace this with 2 into 2 plus 1 by 2. So I'm just going to do that. So, okay, this is much more better, best algorithm, let's go. This is all good to go. Now the problem is, if I do like a production change, either I will have to kind of opt for a reverse proxy or something to do like a AD deployment or something like that. In Beam, you don't need to. Again, it is designed for telecoms. If you want to update the code, you can just update the code, and I'm going to show you that. First, I had to draft a release. I'm going to draft the release, and then I'm just going to say, take this, and I think I just need to say, I have a script for this. So if I just say mix upgrade, it's going to update the system. You can see none of the requests or none of the jobs are dropped. It's still doing it. If any job was running, it will still run. But now I can do 9999999. It will still be blazing fast. And the 13 error is also fixed. All this in a system that I never needed to bring down. It is just running. It's just there, and it's all good to go. Right? There is also no reverse proxy, no nothing. This is just Beam. Right? And I'm going to show you one more awesome feature. So this is
Is there fallback? Can you roll back?
No, you just need to upgrade the previous code. Upgrade but with the previous code. Once you kind of know the system, there is a version system in between, but you don't even kind of use it. You can just say like roll back your Git, but issue that as like a new release. So you can kind of do that. So this kind of gets allowed for that. And one more thing which I'm going to show you, which is super cool, is what is the other thing that web services do when you had to kind of scale? You do horizontal scaling. And how do you do horizontal scaling? Yeah, you have more machines, right? So I'm going to simulate more machines. And one thing Beam actually has is Beam has actually solved distributed computing to a bit. So what you can kind of do is, if all of the Beam machines are, you say to Beam that okay, you are running this application, you are part of this thing. There's a thing called Erlang distribution, where if you give it away for all the other machines to basically connect to each other, it will form a mesh network, and the entire cluster will load balance with each other. So I can actually show you that. So I have a script to start a new server, and it's going to actually start the server. And now there's actually two servers running. So you can see one server will be running 4001. And if you see, the successful jobs per second actually went down. That is not because the jobs failed. Half of the jobs actually went to the new system, right? So this is actually pretty cool, right? So I just spun up a new system. I said, go into this. I just said, okay, you guys are all part of this one cluster. It actually goes there. You know what is more cooler? So I have written code for this, but I can kill this. Oh, wait, I didn't kill this. Okay. I can kill this, and all of the processes. Wait, which processes? All of the processes will come back to the main machine. And by the way, if there is any running process, if you use the proper OTP abstraction, which are gen servers, even the state will be rebuilt back onto the other system. So it is actually a pretty cool system. So again, this is written for telecoms, and they need this kind of stuff. So this is actually pretty cool. No Kubernetes, no reverse proxy. This is all just me, right? So that's kind of the gist with Alexa. Any questions about anything that happened so far? I went a little bit fast, yeah.
So if it is calculating a large number, right? So when you stop one the code, right? Yeah. Then you said that the state will also get transferred.
Yeah.
So it will continue from where it was stopped.
So basically, I think it will drop one function execution. I had to kind of check in the documentation for that. You had to read that because this is a very delicate thing. One thing in Beam though is, especially with Elixir is immutable. So all the data structures are immutable. So there is no mutable structures. If you get resources, the resources are itself processes. So you just send messages to the processes to update files and that sort of stuff. So that will happen normally. So if you do like any side effects, that will go. But what you can kind of do is, if other nodes know where this node's or this process's execution point is, it it can basically take that and bring that back up. I think it is to the level of a function granularity. So you can just restart that function. You have to look into the documentation of how a gen server works. That's the abstraction that kind of provides this. It's a part of OTP, so it's a very good mechanism around that. And also this costs. Generally in Beam, it is always basically it is always optimized for the benefit of everyone versus like a maximum throughput. So if you do like a comparison between Python and Elixir in like a benchmark or something, it is not going to perform as well because it can actually make that. And even here, this robustness stuff will have its own performance costs. It's just a balance. It's a trade-off that they have taken. Any other questions regarding this? Distribution itself is like a very big topic in Erlang and Elixir. I'm not going to go into that, but this is the idea. If there are no other questions, then I can proceed. Okay. Cool.
If there are different physical computers,
Yes.
can you just connect them?
Yes. As long as they are in the same network, they can talk to each other. It will work. Latency will be there. You have to be sure about latency. You can configure priorities to different machines and how fast near things are. Are you familiar with Fly.io? Fly.io is like a cloud provider. I think it's like a very good alternative if you're trying to do something like Heroku or something. It's very hands-on. Fly.io fully runs their entire front end is on Elixir. I forgot to actually kind of mention Fly.io there. And in Fly.io, if you want, they have a very good networking system where if you want, you can say you can define one project in multiple regions. And all of these regions can will be connected to each other with a WireGuard VPN basically. So if you do that, you can even have like global Elixir clusters. And you can kind of like do that sort of stuff. And Fly can manage like routing current requests to the current region and that sort of stuff. You can do that. There's also another cool feature that I will kind of show. Okay, cool. Now coming back, Ranjan, this is DHH by the way. I don't know if you know. Ranjan, I like DHH's face regarding this stuff. He always has like a serious face. Okay. So this is the part of the rant I was kind of talking about. So again, DHH has this blog post called Merchants of Complexity, which is basically if you see around like there are a lot of services, especially AWS, GCP, DevOps. Again, by the way, half joke, half not really. In Hospitals, we have one DevOps engineer, and I speak to him, and I am very convinced that DevOps is basically a pyramid scheme of sorts. So we had a full discussion. So I kind of talk about merchants of complexity there. So basically, like you have all these like really complex systems, and you have like people to kind of do that. You have services to kind of go through that. And one of the things I kind of see is they solve a problem rather than removing the problem, which makes sense because if you are just solving a problem, you can sell that solution. Whereas if you remove the problem, you cannot sell that, right? So I'm kind of skeptical around that thing. So to kind of prove my point, I just went to AWS's documentation, and they have this reference architecture for video encoding. Okay, and not video encoding. This is WordPress. This is literally from the documentation, by the way. I know there are a bunch of these stuff, and I know, yes, if you want to go like global scale, you will need all of these stuff. But doesn't this seem so much? And also, doesn't this seem very expensive? And it is. So that's that. And so that is actually kind of a problem. And the problem, the main problem I kind of always think about is, I think I'll go to that in another slide because I will come to another AWS slide. But I think like what AWS uses is, wow, I have way too much money, and that is their ICP. So this is kind of what I feel that AWS team kind of looks at like people are made out of money kind of stuff. So so this is actually something very real. This is actually something. A story that developed literally over the week. So consider a video processing pipeline, and basically you're taking the video, you're processing it in some way, and you're storing it in some storage. right? This is AWS's reference architecture for that. You take the source, you put it in S3 bucket. You also do Glacier if you want to kind of do like store optimization. Then you go into step functions to kind of process the thing. Then you go to SNS because the other steps basically might need SNS or something to basically notify other systems. Then you do elemental media convert because if you use a lambda, lambdas can have time limits. And if you do time, if the processing you are doing is very big, lambda will fail. So they have a separate service for that. And you have that. You have all of those things with CloudWatch, all of these things. This is their official like reference architecture. Right? And this is the kind of situation. If you're going production workload, you need kind of this going on. At the end of the day, these are all just FFmpeg wrappers. That's kind of the point. All of the modern media infrastructure is all just FFmpeg. This elemental media convert is just fancy word of saying, hey, you wrap that on FFmpeg. Okay. And the Elixir code for just doing this FFmpeg kind of just looks like this. Right? This is kind of to prove my point. So this is basically, I have this something stored in a path. I'm going to run FFmpeg on my machine, and you do that. Now, what's the problem with this? Video encoding is expensive. So if you run a server, you are going to have issues with the throughput. However, if your requests are coming in, you may not be able to serve a request because your entire OS is basically chugging along with FFmpeg. So we don't want to kind of do that. So what do we usually do? We usually move this to another server. So you have a worker server. So what do you kind of do for that? What do you guys do? I don't know. I think some of us have done something like this. So probably we move this to another machine. If you are within like a cloud, probably you will go for like a serverless or something like option. Again, if your video is like very big, then even that is not a problem. That is going to be a problem because AWS Lambda and whatever the alternatives are have execution limits. Cool. Then maybe then after that you have the next set of problems, which is basically how to handle errors. Like if a conversion fails, what to do that? How will you do QA? All of this becomes a problem, and you can see AWS is right there to actually sell you the next service to deal with that. So that's kind of the thing. This is the Elixir code to kind of do this in one machine, and I'm going to introduce to you. So this is like we do that, and I'm going to introduce to you a very cool library called Flame. This is part of this is like an Elixir library. This uses the Beam. So remember, I kind of showed you that we can kind of like distribute workloads into different systems, right? With the Elixir workloads. So we actually have this. So I and Kiran, we have this side project that we are working on, not open source, called CB. Ria is also working on that. So when Ria was saying about Beam Elixir, Ria also works on Beam Elixir. TV, and there we process session recordings. And currently we are like in internal testing, but one of our internal testers is Mufid. So Mufid just released a project called Claudia, and I think the other thing was also there, another project for us was also there, but I think we just did Claudia. And the problem was Claudia, with Mufid's popularity, Claudia was like pretty big, and our servers basically started catching on fire. Because there was literally just one server. It was running Beam, but again, you cannot defeat physics. So ultimately, we wanted to kind of have some scaling situation, and we kind of ran into Flame. And what Flame does is basically, you can literally just wrap your whatever you want to do in a Flame function call. It will execute that function in another worker, and the return value will be just moved into your machine, all over LM distribution. So how does this look like? So this is the code to kind of run this in one machine, to spread it across a set of worker nodes. Wait, it's just this. You wrap it with the Flame code, you just pass it the worker pool, you wrap the function, the return value will be passed outside. So in, by the way, in Elixir, the last value of a function is implicitly a return. So this Flame node call will return whatever the return here. So this entire function literally works as this, like it does the same thing, just the work is offloaded into a separate node. So this will actually block, so Flame node call will block this process, but again, in Beam you can block processes because everything is a process. So you can just block that, but it is not doing any CPU bound stuff. So you are good to go. Your server can still go do things, and it's actually pretty cool. And for us, how it kind of does is we are hosted on Fly, and what we kind of do is Flame has a Fly backend, and what it can do is it will actually, when the load increases, the Fly backend will just go to Fly API, say make a copy of this machine, set these environment variables. So it sets a Flame pan node environment variable, and I have set it on Fly that all of these machines are part of like the same group. So why I can't connect them? And through airline distribution, they will connect with each other, and they will basically send the information, and it will basically kind of manage that. And it's a runner tool, so I can say like within one machine, I can run like 10 things, or within one machine, I can run like 20 things, and I can say like how many machines I can have max. So I can say like 20 things. So if you want to kind of see that in live, so. This is actually production, by the way. Hopefully, nothing has gone down. Okay, I have to log in. Oh, this is possible. And yeah, okay, I have it here because I was dealing with that. So currently, because of Muffiz, we are dealing with like a 9.6. This is a queue. Auburn is our queue system, and it has a very good, nice dashboard. And it's kind of doing that. And what it kind of does on Fly is if I do. If I look at machines, it has actually spawned a bunch of Flame workers to kind of do that. So it actually spreads the load across, and it kind of does that. Once the load is actually reduced, it kills it off. It dynamically downsizes. Again, this is, and when you think of the Fly backend is really complicated, no. The Fly backend source code is only literally 150 lines of code, right? Literally, the only things which are complicated there is basically sending out the machine configuration, the container stuff, and that sort of. And literally every other code is as verbatim as here. I just literally pass it the ID to connect to. Spawn monitor basically means if this thing crashes, I want to know. This is part of airline's robustness. There's a thing called supervision tree, and it kind of does that. And it literally just sends the function, and this kind of does. And when it's idle, it just idle. That's it, right? Very simple. Okay, so that's the other awesome thing, because this is all running within the beam. The beam is sort of like an OS. So the next question will be like, okay, now I have kind of going on this way, but I have more load. So I need durable execution. So to do durable execution, you mostly go for queues. So you want to do queuing. So how do you do? There's a library called that Auburn, I just showed you. And Auburn can just do that. Now you will think setting up Auburn will be complicated. You literally just install this dependency, and you just literally write the worker, and that's it. This is the same code as before, we just wrapped it in Auburn worker, and said this is the queue, and that's it. You now have the queue, the Auburn worker actually runs on the server system. The Auburn worker actually runs on the server system. The perform basically runs on the different worker nodes, and it all communicates together like seamlessly. There is no API. You don't need to write up APIs. It is sort of like microservices, but you don't actually write microservices. This is at the end of the day just a monolith, and you basically just work off of that. And that's what I want to kind of go at. Even more than products and solutions, code is really good at solving these problems. So it is actually really cool to, if you want to kind of like just solve this way. Beam can be the OS to actually run this entire platform. And that's not all. Just to kind of wrap up the whole thing, I'm introducing Phoenix. Phoenix is the, as I said, the Rails equivalent to it. And their literal motto, which is actually what I really love, peace of mind from prototype to production. And that's kind of the thing. As a person who actually literally runs a free service on, as free at the moment, but we will make you pay because LLMs don't come cheap. Phoenix framework. Alright, there's Phoenix, and it's actually really cool. Phoenix actually takes us further. It gives you a mailing system, it gives you a database, it gives you a very good ORM, authentication and stuff is just one command to implement it, all of the stuff. All of the stuff is just batteries built in.
live view.
Yeah, I will explain live view at the end. Yeah. So, and literally that also kind of shows in the Stack Overflow survey for the past 2 years in a row, it was the most loved web framework. Yeah, right people, you are in shambles. So, yeah. And this JavaScript sucks. So again, one of the things, especially with like us three, it's like this is our side project. Like Chief is our side project, and we don't exactly want to spend a lot of time trying to build this. So one of the things we want to kind of do is like we want to reduce as much as complexity as possible. So we just don't write JavaScript. All of the application you kind of see. Wait, I can actually show you. Is this a product demo? Yes, it is. Okay. All of the JavaScript around here. It's like if I change something, all of the JavaScript around here is actually not JavaScript. This is always just Elixir code. The Elixir is rendering this UI. Elixir is kind of processing everything. It's just all Elixir. I mean, I can also kind of have access to whatever is happening in Claudia. What are the users doing? This demo can go super wrong. Ria, does this work?
If the AI credit that.
Okay, let me try explore. What are the other users are recorded? Let's hope this works. And this, again, even now, it's not, none of the things are JavaScript. This is all Elixir even now. The code is basically there. And there's a thing called live view. I'm not going to explore live view too much, but that entire native interaction is basically just Elixir code. What happens is every time a user kind of comes in, it is a live view process, and within the live view process, you can like update its state and update its state, and that will be transmitted over through the server. So this is not really good if you're wanting to do very client-side heavy interactions. In our case, ours is basically a dashboard and this engine, so this question answering thing. So for us, it's kind of fine. If you're doing very interactive stuff, you will still need JavaScript because everything you do kind of will do a network hop. It's kind of stuff, right? Really awesome. So the main point here is you can get so far with literally this one thing. Right? And that's kind of the thing. So a lot of companies, so this is from a case study with like a company who adopted, who was kind of building a service, and they did a service with Ruby on Rails and one with Erlang. This is a little bit before Elixir was there. And they had all these different stuff. You want to do a long running request, you do something. Go, you need server state, Redis. You need to kind of do persistable data, you have a database or Redis, all the stuff, background jobs, Redis, Ruby or whatever, and you to recover from crash services, you have that Beam is written with service crash recovery in mind. So all of these stuff are basically sorted out, and that's the thing. Start simple and go very far. Now the question is like how very far, how much is very far? Beam is a very tried and trusted technology, and so Chris McCord is the creator of Phoenix, and he basically made a Phoenix channel scale on one machine to 2 million clients. Like at 2 million clients, the actual limit you are going to reach is the Linux kernel limit. You cannot have more open TCP connections than that. So a Phoenix channel is basically a WebSocket connection, but with a lot more awesome features. And you can actually see that the major problem he just needs to kind of handle is just his memory consumption, because that's TCP. Yeah, but that's it. There's no other blocker. His CPU is just chilling. He can basically connect it through, and that's actually pretty nice, right? So that's basically the thing I want to kind of talk about. This one really underrated gem, which is, I don't know, this is like exactly written for web services in mind, but it's for some reason not exactly popular, and I wanted to kind of like bring my eyes into your eyes into that, maybe play around with it and see. It is a little bit weird. Mostly it is sort of functional, not like Haskell kind of pretentious functional. You can still do operations like report.1 and update the database. IO monads here, but like you don't have things like loops or mutations. But that's what stuff is actually pretty good. Yep, that's about it. Just a couple of credits. Again, this dash shell is powered by Nix, so Flaky Boys represent. And then the other thing is what else? A lot of my slides are inspired by a really awesome talk that you should actually go watch. I mean, this entire demo system is basically from Sasa Hurek's talk called the Soul of Erlang and Elixir. So you should actually check that out. It's a really good talk. Just reduce it to 0.5x of it is very fast. But yeah, that's about it. If anyone has any questions, I will find that. Like regarding beam distribution or whatever is that.
Are there campaigns for rewriting?
So there's one problem. Again, Beam, it's not. There are like projects to kind of like write native apps with Beam, put Beam in IoT. You can sort of do that. There's a project called Atom Beam where you can now run Beam in the browser and on IoT devices. You can compile it to ASM. But again, two things. Beam is not written with performance like throughput, like actual CPU throughput in mind. Again, it's not one thing should run fast. It's everything should keep on running. That's kind of the idea. So is there? So it won't work like everything in this kind of mechanism. I don't think so. But yeah, if you want, you can kind of use it. And also, environment is very small, and I would say also not very toxic. Us community, wink wink. So it's not very toxic. So it's very chill. I mean, the community is so small. Like if you create a library or something, and if the library is moderately used. Like the language creator Hossein himself will like come and contribute and check out this guy. The guy is also very cool. Yeah.
So can we leverage this to the microservice part?
The whole thing is, why do you need microservices? I mean, this whole thing, you don't need to think about microservices here. It's just this one monolith. The Beam itself can just split into machines. You can sort of have microservices. So for example, the thing I did with Flame, right? The point is basically I want this session processing thing to be elastic and separate from the actual server load, like actual web server. So if you want, you can kind of think about it in that way. But it's like you don't need to exactly think in terms of microservices to kind of get that. But if you have, that's also kind of possible. But generally, even with microservices, you kind of get into other costs. Like with microservices, one of the things you always end up doing is you have to implement some sort of an API and transport mechanism. Beam itself has a transport mechanism, airline distribution. You just need to do that. And it's transparent. You can, any airline object, you can just literally send it to the node. It's just normal, like, you just, like, that's the point here. So if I take the flame call, right? This function is, the flame call function is being executed in a completely other machine, but it gets the path. It automatically moves the path into the closure, and you can do that. Beam has a very small number of primitive types, so it knows what all things can be moved. Also, by the way, other thing you can also do is basically, you can even be like, okay, you can open a file in this machine, in the server machine, and you can open the file in the server machine, and then you can just pass that file instance into another machine, and if the other machine tries to write the file, it goes through the LLM distribution and updates the file on the other machine. You can even send files across machines. It's all good. Again, a file is a process, so the file process will always run in the machine which is where the file is. So when you do this, you basically messaging that process. That message is routed through LLM distribution.
What's a good place to learn?
Okay, this is one problem that compared to Ruby, Elixir is still not properly solved in my opinion.
I tried reading the book first.
Yes, I would say read the documentation. There are some YouTube videos. Even the YouTube videos are kind of meh. One thing I will kind of recommend is so like how Rust has docs.rs, Elixir has hex docs. So you can find Phoenix here. Then it's just experimentation. A lot of things is you have to experiment and see. This is one of the parts of Phoenix that I think they actually need to improve a bit. This is that onboarding process. It's not because it's difficult. I mean, the things are basically simple. But the problem is it actually gives you a lot of features built in that like a lot of time will be wrapped around like how to think at that. There are some books. There's a very good Sasa book called Elixir in Action. That is a very good read. That actually gives you a walkthrough through Phoenix. That's a very good read. If you want to kind of go through that, that's actually a pretty good start. I think that's the only thing. The other stuff is very depressingly bad compared to something like Ruby or like JavaScript. Any other questions?
Can you run Beam on Kubernetes?
You can. So there's a fly backend. I talked about Flame, right? If you want, if you are, I think Kubernetes has like an API system that you can kind of use. If you want, you can say Flame to use the Kubernetes system to kind of spin machines up and down. Yeah, you have a question.
So it's purely asynchronous?
Asynchronous as in? So the way it kind of works is Beam processes are asynchronous. What it depends on what you kind of define as asynchronous. So for example, Python or JavaScript implements asynchronicity with a thing called event loops. So it's basically a big while loop, and in the while loop, if there is any work to be done, which is basically there is like something that is awaited. If there is something that is awaited, keep on checking if that await is basically resolved, and if so, execute in a continuous kind of stuff. In Beam, it's sort of like how Go does it, where you kind of do that. It may run on a separate thread, or it may not run on a separate thread. That it depends. It's green threads. I think spinning one green thread on Go, it's like around 2 kilobytes. I think 2 megabytes?
2 KB.
2 KB. On Beam it's 0.5. So you can spin up how much ever you want. And it's a green thread. So it will preempt. So it will basically on the CPU side, similar to how your OS processes work, Beam just implements that in the Beam level. So it will preempt operations in between. Actually, that reductions that I showed you before, that's basically where the preemptions happen. Usually preempts are function calls. Yeah. Yeah.
Is this just similar to temporal service?
Temporal as well?
There is a service called temporal IO.
Okay, let me check that out. What is that? Hero execution. There are a bunch of stuff like this. I saw Cloudflare have like their new agents thingy, which is sort of like this. Durable execution, all of this stuff. You don't think about this in terms of you just basically run through the process. The process will just keep on running. If you want it to be durable, you have to somehow store the state in the database. That's it. That's the only thing you need to worry about. That's something you can architect. That's not a very complicated thing. This is not a very complicated thing to run. I have this as a major pet peeve against the JavaScript people. Who runs JavaScript in production here? Like backend servers. How do you guys run a cron job? Or like a job that needs to be run on like a time?
We call this script, that's it.
In essence. Okay. I mean, yeah, it was. Why though? That exactly is kind of my problem. That shouldn't be the way things kind of go. Like you cannot access things like that's the other thing I want to kind of talk about in Flame. Just want to show one more thing in the Flame slide. This video store could just be a database. Within the Flame code, it's still, even though it's running on a separate working node, it's not like a half-assed runtime like what AWS Lambda or something is. This is your full Beam runtime running with your application. So if you want, this will have access to your database. If you want to have PubSub, you don't need separate mechanisms like SNS or Redis to do PubSub. Beam has it built in. Phoenix has a thing called Phoenix PubSub. You just do that. That's just there, and you can do that, or you can access the database. You can talk to other machines, all just from this one call even. So it's actually pretty cool. You can kind of do that. In Beam, what you would do for like something like a cron job or something, there are literally functions for that. You can either use Auban. Auban is a little more complex mechanism though, but there are other projects where you can basically be like, you can literally just put in a decorator that you want to run this like a cron job, and it will just run it. It basically starts up as a process when the server starts, and the process will wait for this amount of time, and then it can do the operation. Okay. Any other questions? No? I think we might have. Right, that's about it. Thank you guys.
Alright, thank you Andrew, that was a really good talk. informative, entertaining, and all nicely packaged into a talk. Okay, so next we'll have a small break, a 20-minute break, and after that we have an open discussion which is called community dialogues, and we have a few folks ready with questions and discussions to topics basically. So let's split for a break and we'll see together in 20 minutes. Tea and snacks are arranged over there. Thank you.
Mirshan, so is there anyone who doesn't? Okay, Marathi പറയാം. ഈ BOF അഥവാ ബേർഡ്സ് ഓഫ് ഫെദർ അഥവാ ഒരേ തൂവൽ പക്ഷികൾ എന്ന് എന്താന്ന് അറിയാത്ത ആരെങ്കിലും ഒന്ന് കൈയ്യുണ്ടാവും. ബേർഡ്സ് ഓഫ് ഫെദർ അഥവാ ഒരേ തൂവൽ പക്ഷികൾ എന്ന ഈ സെഗ്മെന്റ് ഉദ്ദേശിക്കുന്നത് ഞങ്ങൾ 3 മോഡറേറ്റേഴ്സ് ആൻഡ് ലൈക്ക് മാർക്ക്. ഞങ്ങൾ കുറച്ച് മോഡറേറ്റേഴ്സ് ഉണ്ടാവും. ഇത് ഞങ്ങൾ പറയുന്നത് കേൾക്കാനല്ല നിങ്ങൾ ഇരിക്കുന്നത്, നിങ്ങൾ പറയുന്നത് കേൾക്കാനാണ് ഞങ്ങൾ ഇരിക്കുന്നത്. സോ നമ്മളൊരു ടോപ്പിക് സെലക്ട് ചെയ്തിട്ടുണ്ട്. I mean, a bunch of topics are there. So we just need a community input. Asli, നമ്മൾ Kochi FOSS ആയിട്ടുള്ള ഈ കമ്മ്യൂണിറ്റിയുടെ takes എന്തൊക്കെയാണ്? We have takes. It could be any kind of takes. You could just share those takes with us, and like we'll be like kind of moderating it. At least we'll try to. So to start things off, finally we are feeling like this is the year of Linux desktop. And every year we do it. We are kind of in a closed, or we'd say like an echo chamber എന്ന് പറഞ്ഞാൽ കറക്റ്റ് ആ മറ്റേ കൊച്ചി ഫോസിന്റെ ടെലിഗ്രാം ഗ്രൂപ്പിലൊന്ന് ഒരുത്തം പറഞ്ഞ പോലെ എക്കോ ചേമ്പർ എന്നൊക്കെ പറഞ്ഞാൽ ചിലപ്പോൾ ശരിയായിരിക്കും. ബിക്കോസ് നമ്മുടെ സർക്കിൾസിൽ ഏറെക്കുറെ എല്ലാവരും ലിനക്സ് യൂസ് ചെയ്യണ്ടാവും. പക്ഷേ അത് നമ്മുടെ സർക്കിളിന്റെ പ്രശ്നമാവാം. അപ്പോ ഈവൻ outside our circle people are starting to notice. I mean PewDiePie ഒക്കെ followers എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ exactly. Okay, so the topic is mostly gonna revolve around like PewDiePie's last 2 videos. Is it last 2 videos? PewDiePie is last Linux videos. Okay, de-Google and then there was like I tried Linux, I guess. So ഈ ഒരു ഇത് കാരണം എന്താ നമ്മുടെയൊക്കെ ഈ ക്ലോസ് സർക്കിളിന്റെ പുറത്തായിട്ടും ഒരു നോർമൽ ഓഡിയൻസ് പോലും ലിനക്സിനെ പറ്റി കൂടുതൽ അറിയാൻ പോവുകയാണ്. സോ ഇതിനെപ്പറ്റി നിങ്ങളുടെ ടേക്സ് എന്താണ് എന്നൊക്കെ ഉള്ളത് എതിർക്കാനാണ് നമ്മൾ സ്റ്റാർട്ട് ചെയ്യുന്നത്. സോ എനിവൺ
ഇൻട്രഡക്ഷൻ കൊടുക്കായിരുന്നു.
എന്തോ
PewDiePie ഇൻട്രഡക്ഷൻ
PewDiePie എന്താണ് പറഞ്ഞതെന്ന് ഒരു TLDR ആൻഡ്രൂ പറഞ്ഞു.
സോ ബേസിക്കലി PewDiePieന്റെ സ്റ്റോറി അറിയാൻ ഞാൻ PewDiePie 2013 തൊട്ട് കാണുന്ന ആളാണ്. ഞാനൊരു OG അല്ല സോ ആ ഫ്ലോർ ഗ്യാങ് അതെങ്കിൽ പുള്ളി എങ്ങനെയാണെങ്കിൽ വേറെ ആരെങ്കിലും PewDiePie ഇങ്ങനെ പണ്ട് കണ്ടിട്ടുള്ളവരോ അല്ലെങ്കിൽ സസ്റ്റൈൻഡ് ആയിട്ട് കുറെ ആൾക്കുള്ളവരോ? ഓക്കെ സോ to kind of give you just PewDiePie ഒരു കാലത്ത് ഒരു കാലത്തൊന്നല്ല he used to be the most subscribed YouTuber. ഇപ്പൊ I think he is the most subscribed individual YouTuber. I think ബാക്കിയുള്ളതെല്ലാം കമ്പനീസ് അല്ല ഇപ്പൊ കമ്പനീസ് ആണ്, നോട്ട് an individual. മിസ്റ്റർ ബീസ്റ്റ് ഇൻഡിവിജ്വൽ ക്രിയേറ്റർ ആണോ?
മിസ്റ്റർ ബീസ്റ്റ് കമ്പനിയായി മാറി.
കമ്പനിയായി മാറിയില്ലേ? ബട്ട് ജനറലി യെസ് ഒരു കാലത്ത് എനിവേസ്. ആൻഡ് പുള്ളി അത് കഴിഞ്ഞ് പുള്ളിക്കാരന് കുറച്ച് പൈസയും കാര്യങ്ങളൊക്കെ ആയി. ആൻഡ് ഓൾസോ പുള്ളിക്കാരൻ വാസ് ലൈക്ക് ഒരു പരിധി കഴിഞ്ഞ് എനിക്ക് ഇതിന്ന് റിട്ടയർ ചെയ്യണം എന്നാണ് വെച്ചത്. സോ ഹീസ് കറന്റ്ലി ഇൻ ഇസ് ലൈക്ക് റിട്ടയർമെന്റ് മോഡ്. ഹീസ് ലൈക്ക് ചില്ലിങ്. യൂട്യൂബ് ചാനലുണ്ട്. യൂട്യൂബ് ചാനലിൽ പുള്ളിക്കാരുടെ ഇഷ്ടമുള്ള സാധനങ്ങൾ നമ്മൾ കോണ്ടന്റ് ഇടും. അത് ഇൻട്രസ്റ്റിംഗ് ആണെന്നില്ല. ചില സമയത്ത് ഒരു ദിവസം വന്ന് ബുക്ക് റിവ്യൂ ഒക്കെ ഇട്ടിട്ട് പോകും. അപ്പൊ ആൾക്കാർ വന്ന് കാണും. ഇതുണ്ട് അങ്ങനെ കുറെ കാര്യങ്ങൾ പുള്ളിക്ക് ഇഷ്ടമുള്ള ടൈപ്പ് കാര്യം ചെയ്യുന്നു. അപ്പോൾ അതിന്റെ ഇടയ്ക്കാണ് പുള്ളി ഹി കൈൻഡ് സ്റ്റാർട്ട് തിങ്കിങ് അബൌട്ട്. അപ്പോൾ പുള്ളി ജപ്പാനിലേക്ക് ഷിഫ്റ്റ് ചെയ്തായിരുന്നു. അപ്പോ പുള്ളിക്കാരന് ഇപ്പൊ കുറെ കൂടെ ഫ്രീ ടൈം ഉണ്ട്, ആ ഹസിൽ അല്ലാത്തത് കാരണം. ആൻഡ് ഹി സ്റ്റാർട്ടഡ് കൈൻഡ് ഓഫ് ലുക്കിംഗ് ഇൻ ദിസ് ടെക്നോളജി സ്റ്റഫ്. ആൻഡ് പുള്ളി നോക്കുമ്പോഴത്തേക്ക് കുറെ ലൈക്ക് 1-2 കാര്യങ്ങളുണ്ട്. ലൈക്ക് ഒന്ന്, വിൻഡോസ് ഇസ് ഗെറ്റിംഗ് ക്രാപ്പിയർ ഡേ ബൈ ഡേ. ആൻഡ് രണ്ടാമത്തെ ഇത് പുള്ളിക്കാരൻ ആസ് എ ക്രിയേറ്റർ അഡോബിയുടെ സ്വീറ്റ് യൂസ് ചെയ്യുന്നുണ്ടായിരുന്നു. ലൈക്ക് വൺ ഓഫ് ദ മെയിൻ തിങ്സ് ഹി വാസ് ലൈക്ക് ഇതിന് ഭയങ്കര പൈസയാണ്. ആൻഡ് ലൈക്ക് വാട്ട് ദ ഹെൽ, ലൈക്ക് സബ്സ്ക്രിപ്ഷൻ ക്യാൻസൽ ചെയ്യുന്നതിന് ഫീസ്. Not even kidding, it's actually a thing that Adobe suit cancellation fee. So he was kind of like എന്റെ കയ്യിൽ നിന്ന് ഈ സാധനങ്ങളുടെ കൺട്രോൾ പോവുകയാണ്. ബട്ട് ലൈക്ക് വൈ കാണ്ട് ഐ ഹാവ് കൺട്രോൾ, വൈ ഡോണ്ട് ഐ ഹാവ് ദ ഫ്രീഡം ടു കൈൻഡ് ഓഫ് ഡു ദാറ്റ്. അപ്പൊ പുള്ളി ഇങ്ങനെ ലിനക്സിൽ പുള്ളി പറയുന്നത് പുള്ളി പണ്ട് ലിനക്സിനെ കുറച്ച് അറിയാവുന്ന കുറച്ചൊക്കെ ട്രൈ ചെയ്ത് നോക്കിയിട്ടുണ്ട്. ബട്ട് ലൈക്ക് സീരിയസ് ഇതിൽ പോയിട്ടില്ല. അപ്പൊ ഇത് വന്നപ്പോൾ ലിനക്സിന്റെ കോൺവെർസേഷൻ ഒന്നും കൂടെ വന്നു. ആൻഡ് ഹി കൈൻഡ് ഓഫ് വെന്റ് ഇൻടു ഇറ്റ്. അപ്പോൾ പുള്ളി നോർമൽ ഒരു ഇതിൽ കൂടെ തന്നെ പോയി. ഐ തിങ്ക് ഹി ഇൻസ്റ്റാൾഡ് മിന്റ് ഫസ്റ്റ്, എന്നിട്ട് ഇൻസ്റ്റാൾ ചെയ്തു. എന്നിട്ട് ഹി വാസ് ലൈക്ക് ഓക്കെ ദിസ് ഫീൽസ് ഗുഡ് എന്ന് പറഞ്ഞിട്ട് ഹി സ്റ്റാർട്ടഡ് ബിൽഡിംഗ് ആൻ ആർട്ട് സെറ്റപ്പ് ആൻഡ് അങ്ങനെ പോയി. ഹിസ് ഫസ്റ്റ് വീഡിയോ പുള്ളിക്കാരൻ തന്നെ ആ വീഡിയോ തന്നെ പറഞ്ഞായിരുന്നു. He has used little bit, not like, I mean, he knows his way around it somewhat, but you can still think he's not like a programmer or anything.
But he jumped to arts pretty fast.
Yeah, mint to arts. That's a normal jump. These days, a lot of people start with arts as well. Arts now comes with, back in my day, arts installs used to be like a one-day process. My first arts install, I remember I had Arch Wiki open. Good thing was Arch comes with Arch installer comes with W3M, so it's like a terminal browser. So I opened Arch Wiki in W3M and I basically like do all of the steps one by one, slowly. That's how the system was. I think I got the GUI running in the second day. That's how much time it took. But these days Arch actually comes with a tool called Arch Install. So now it's like easy. Kids have it easy now. That's what it is. By the way, all three of us are flaky boys. We are mixed users. But we will guarantee you that there is not going to be any bias towards that. But anyways.
Andrew's lost of blue dollar.
Yes. Anyways, so that's kind of the gist. So he is basically trying to kind of take back, like his story is basically, his first video was he literally said, okay, in the day I wanted to kind of show you all of these things. I mean, but my main goal was just flexing my art setup. But he legit said that he rice it is a very good rice. And he basically wanted to show that. And on the second video, he was basically just going further, where it's not just about his machines anymore, but it's also about like the other services he used. So like he was talking about like where he stores his files, note taking, password management, browsers, all of this stuff, and like where should it be. And another concern which he was talking about was more around privacy and trying to keep everything like within this. Like if the thing is free, you are the product. So that kind of a vibe. So that's what most of the two things are. One interesting thing about this, I mean, just to add on my personal experiences. Again, I have friends who also used to watch PewDiePie with me and who still watch, and he is not exact. And like one interesting story I had is a friend of mine who is a medical student. He is a doctor now. He used to watch PewDiePie, and he actually reached out to me after the first PewDiePie video. It's like, I know you kind of talk about Linux, so I saw the Pewds video. It looks very cool. I want to try it. So it has actually had serious impacts. Like a lot of people have seen this. I mean, to add on, I'm not even kidding. Literally last night, I was in Bijoy's burger shop with a friend of mine who is a mechanical engineer, and I was actually installing Mint on his machine. That's how I started yesterday. So on my
what's the default GUI that Mint comes with?
Cinema. It's very good for people who are coming from Windows. Plus the problem I used to recommend.
Cinema is no.
No, it's all built on GTK. Yeah, it's built on GTK.
GNOME 2 and 4K.
No, it's not
Okay.
Mate, okay, sorry.
Mate was GNOME 2.
Yeah, this is built on top of GTK4. So
also with NVIDIA drivers also.
Yeah, so it's very beginner friendly. The documentation, it's not very big, but it's very beginner friendly. No, it's still X11. There's an experimental Valence session. No, but mostly it's very easy for Windows users to kind of because the UI is very okayish in terms of our Windows. But more importantly, like usually I used to recommend Ubuntu to people. But Ubuntu, the last time I used it, I was not a very big fan. Snaps are a confusing thing for a bunch of people. Snaps got a little bit better recently, I heard. I haven't tried. But Ubuntu has been pretty weird. Mint has been very user focused in terms of things. Like one metric, so when this started happening, I kind of did like a benchmark of different distros, and one of my metrics was like, again, I'm kind of driving into the point, but it's basically, I like the people who are going to be coming for the PewDiePie videos, okay, they might, okay, asking them to use the terminal is fine. Pewds uses the terminal, Pewds has SSH and everything set up. But I'm not expecting everyone, like my doctor friend, I'm not expecting him to use the terminal. So like one of my policies is like, if you ever test if the user has to ever test the terminal, that distro is disqualified. And Mint is one of those beginner friendly ones where you don't need to actually exactly worry about it. The rest of the stuff I won't deem it very well. So it is actually like a very growing movement. So yeah, that's my point to it.
Like similar like PewDiePie or recently you drive like non-Linux user based friends showing up or like asking you stuff. Yeah. Thank you. Can you do anything?
I'm Arjun. I've been coding from like since COVID started. I just graduated from 12th.
Yeah.
I just graduated from 12th and I'm joining Christ in Alakura next month. I'm in a pretty big game dev community. It's called the Brackies community. It's a
Brackies.
Yeah.
Oh, but didn't Brackies kind of like stop?
But he stopped. Yeah, but he came back for.
Oh, okay.
But he came back for another game engine. It's an open source game engine. Go dot.
Yeah.
I have a lot of friends there, like who I've been friends with for like 5 years. They've all been hesitant to try out Linux. But I noticed that a lot of people would suddenly everyone was just converting to Linux these days. And I like took a survey. I asked everyone why they were converted to Linux, and I realized that all of them, like except one guy who was an arrogant British guy, all of them they were moving to Linux indirectly or directly because of PewDiePie. It was either because they watched the video themselves, or they were inspired by their friends.
Yeah.
Like it was a chain effect. Like
chain reaction.
One guy, I actually saw the entire thread. One guy posted PewDiePie's video in the chat, in the main chat. Some guys started talking about it, and then a few of them installed Linux, and a few of their friends installed Linux, and it just came down. And it's like a good half of the whole community is like have installed Linux now, and some of them are still trying to, and they've all been hating Linux so like until this point. That's it.
What is the entry point in Linux? Earlier it used to be Ubuntu, right?
Yeah.
Is it still that low-level entry point?
I mean, for a lot of people, Ubuntu is popular. So one thing with that is like all of the documentation, that sort of stuff, is written for Ubuntu.
Ask Ubuntu
is there. It's a very But I start people off with Mint. Mint's forum is pretty good. You had to ask out. But
Debian-based also, right?
It's Ubuntu.
There's a
separate Debian-based version.
LMD.
Yeah.
These days, I think a lot of people also start with Pop OS.
But I don't recommend Pop OS.
Yeah, I also don't like Pop OS, but
No.
They have some firmware issues.
They have firmware issues, and they haven't updated a bunch of stuff. They have very slow updates.
yeah, like if you search for gaming center, so if someone searches like I want to game on Linux, probably the distro that will be recommended is Pop OS. That is why
Again, that could be like circle problem. There is also gaming focused distros are becoming a thing now. There is SteamOS, but SteamOS is not like Nobara, all of these things are there. I have a Steam Deck, by the way. I mean, there are one.
Yeah, so one of my seniors when I was in college, he used to be like a hardcore gamer. Okay, so he switched from Windows to Linux so that he can't game anymore. Okay, it was to like de-addict himself from like gaming. Currently he works at Oracle, but like he last day he saw me and like, man, Linux is getting so gamer friendly. I might have to go to FreeBSD or something. And yeah, that's it.
There's even reports basically that some games actually run better. Some Windows games will actually run better.
Yeah, so another friend of mine, he had, so he was also like mechanical student. So for his academic work, he had to use Windows. There was a small partition Arch Linux setup only for gaming, specifically for CS:GO. Okay, so he plays CS:GO and like he was getting much more frame rates than he was getting in Windows. And like actually, the day and night comparison can be tracked with that Steam Deck alternative released by Lenovo. So Lenovo just so they have this same spec machine running Windows and Linux, and that is day and night comparison showing how better like Linux is. And like recently Day 2D or someone released a video. So overall, again, this is looking like truly the year of Linux. And also, how many of you have heard of End of 10? Yeah, so for those who haven't,
Windows 10 is
Windows 10 and okay, so can anyone like volunteer and explain what's End of 10 is?
I don't know what End of 10 is. I know
Yeah.
Windows facing up.
So Microsoft has officially killed Windows 10 by 2025. But unfortunately, we have Windows 11 to suffer with. So End of 10 is
Should we? I don't think let's not have it.
End of 10.
So you could like search up endoften.org. So it's like a like campaign.
Community, like everybody is coming together to kill Windows 10 because nobody wants to update to Windows 11 because it's very bloated, slow,
Yeah, so
crashing.
start is now React.
React Native.
No, the actual problem right now is, according to Microsoft, actually they were going to kill this last year, right? They were going to kill this last year, but the problem was that what Microsoft discovered was they have almost 900 million devices that are running on Windows 10, and according to their statistics, is 400 million of these devices cannot be upgraded.
Yeah.
TPM. Basically the TPM thing, right? And now about 500 million can be upgraded, but those people haven't upgraded. So the thing for them is that's where this End of 10 project I think is coming into, where you can use these 400 million devices instead of like throwing them out, because that is tremendous amounts of garbage, right? E-waste. So I think that is also one of the things.
That's a driving factor.
And another issue is also a lot of these government schools and all that in Europe, and they use Windows 10.
Yeah.
So what another thing Microsoft has done is that they are providing them with extended support for 3 years from 2025 onwards at some cheap rate.
Yeah.
Right? I think $1 per computer or something like that. So I don't know, maybe they'll come up with to make money now, since they're doing it for these schools. They only said schools, and I think hospitals also. Maybe.
Also, I believe there are professional organizations where you can have an extended support for Windows 10 because I think end of life was
So that's crazy, right? Because you don't want Windows 10. It's going to total horseshit operating system, right? So might as well put a good Linux operating system on it, which is where these campaigns come in. I think that's where.
Another thing which happens, especially for like if you are not like a technology focused person, like one thing with my like the doctor friend I was kind of saying, he only uses it to read ebooks, watch movies, browse, and read like stuff. And one thing for him is like his machine was like at that point like 4 or 5 years old, but it can run Windows 11. And Windows forcefully updated it to Windows 11. And then he realized that he cannot use the machine because everything takes 5 minutes to load.
One funny thing is Windows 11 requirements were very high, and because Microsoft saw that nobody is updating to Windows 11, they started slowly cutting down the requirements.
Yeah, but the problem is the OS at the end of the day can't run on like even mid-tier Windows 10 machines. It is pretty bad.
They had this issue back in Windows Vista days. Like,
I mean, so I would say in Windows Vista, the problem was like the hardware didn't catch up with the software. So when Windows 7 came out, by that time the hardware got up.
So they could have put the hardware requirements very high, which they did at first. Then no one really bought it. Then they reduced it, but Aero was Aero. Now Apple has rebranded Windows Aero.
It all comes back.
Yeah. but Windows Aero was too heavy to run, so people had to disable aero effects and things for Windows Vista to run this.
So a lot of the things, especially, it's just like so I was just I should have recorded that as a video. So I was setting my friend up yesterday. This was yesterday night, literally. This was happening, and he brought the laptop to me to kind of like investigate one thing as well. It's just like his machine randomly takes like it's like performance issues like randomly, and he was thinking like some hardware issue was there because it just randomly freezes and then comes back to life. So I was like, maybe it's like maybe your RAM or something might be an issue, I don't know. And then I just checked Task Manager, and random bloatware from like the OEM is running, and then the Windows Defender, that anti-malware executable is running, and at the end of the day you can see like the CPU is like full. And I was telling him like, no, this is just Windows. And then I moved, so then anyways, he came to me to get Mint installed because he wanted it to run, I think, OpenFOAM, which ran better in Linux. OpenFOAM, it's like some material analysis kind of stuff, I think. I don't know. He wanted to kind of do that, so I installed it, and he was surprised by two things. One was basically performance-wise, it was actually pretty good, and then the other thing was which he was like really surprised by was like he had a lot of pet peeves in Windows where he was like, oh, I can't do this, and then he goes into the Mint customization section, and he sees that you can change how what happens when you click anywhere on the double click anywhere on the title bar, or change where the title bar icons are, and he was like, oh my god, that's like insane. He was like telling me, so I was like, I'll be in US, so I told him like I'll be in US for like the 10-15 days because I'll be traveling, but when I come back, and he was like, okay, with the amount of customizations you just showed me, I think I will need more than a month to kind of like figure out what I want. But that's actually pretty cool.
Waiting he discovers rising.
Not even rising. I mean, imagine if I put him in some like AD or something.
So, anyone else has any question? Again, more than us, it's supposed to be you.
Oh, since we're on the Linux topic, another big thing happened was, since we are talking about Linux and Windows, I mentioned this last week. For the first time, Linus met Bill Gates. Right. That was a big photo also. I was quite surprised. I imagined they would have, crossed horns somewhere, and all those things, but that has never happened. And
knowing Linus, I mean, I was expecting some drama to happen.
I was too, and he was very cordial and he was very muted. And the photo was interesting also because it's like there are 4 people in the photo. 3 are Windows people, all like, but I have to say, both the developers are like solid. Mark, I forgot his name. The guy who did that sysinternals. That guy was like hardcore, right? Because I remember because around 2000s and all that, when Windows moved to NT, I think that was before that. This thing used to run, because it's a closed thing, these guys used to reverse engineer because people wanted to put pirated software on it and they wanted to really work through the registries and all that. So this Mark, what's his name, Rusnovich, Mark Rusnovich. Oh, there you go, this photo. So I don't know, it's like, so this guy in the corner, so I think Mark Rusnovich is the guy who called this dinner. So he's like, I can really attest to this guy. This guy is like really hardcore. He's one of the best reverse engineers. Got him and another one of his colleagues. So these guys used to reverse engineer Windows, trying to break into this thing and get basically because you needed the key to get this activated. So they used to figure out ways to break into this, basically jailbreaking, and get this thing to work. And they used to write a whole bunch of tools to sort of investigate the kernel and all that things about Windows. And they used to make it so that became sysinternals. And this guy's like really hardcore. I know that. So I think he called the dinner and he invited. So there's like the photo, right? But everybody's saying, oh, this is amazing, this is great. But look at this photo, it's so, number powerful, Linus is in the middle between 3 Windows guys. He's cornered, right? And the guy, so there's Bill Gates over here, and then I forgot the last guy's name. He's one of the original. He's a long-term engineer. I think. Dave Cutler. Yeah, exactly. So I know Dave Cutler in the sense he worked for Windows, but another thing about Dave Cutler is really weird story is that he's also one of the chief architects of an operating system called, now since you got into Erlang and you were talking about telecom, so there is a operating system called BAS, which DEC came out with, okay? DEC, that company's no more. So this, I'm talking about this guy's like one of the very first operating system engineers around. They started building operating systems in the 1970s. I mean, for these proprietary operating systems, by the way. So DEC and all that were proprietary companies. So BAS was an operating system that they built. And I think it was around 2015, I met an acquaintance who used to work at Verizon. Verizon is the big American telecom company, right? And he mentioned to me like, hey, he was talking to me about their backend system and reliability, and he was talking about trunking and all those things, and he was saying about the moving into 5G. In fact, they started planning on that kind of succession. He said, we have the systems running BAS, right? So that's how I know David Cutler. So BAS was an operating system that was actually built towards the mid-1970s region. So you can just imagine a company like Verizon is using an operating system from the early 1970s, right? And that's a proprietary operating system, but my understanding is that though Unix was around back then, Unix was mostly within the academic circles and is very highly experimental, right? Berkeley and MIT. So on the West Coast we had Berkeley, and on the East Coast we had MIT. So these were the two operating system giants on both sides, right? And on the East Coast, obviously we had IBM Research, we had Bell Labs, all great guys doing this kind of work. And obviously Bell Labs started with Unix, and Dennis Ritchie and Ken Thompson, who can forget this, right? Cutler is one of the original architects of that VES system, which surprisingly is still being used after 40 years. And the thing was, this friend was telling me, this VA system that they put, this thing is like incredibly, and I think I called somebody back. Okay. So he was telling me that some of their architecture over there involves clusters, but because they need extreme reliability, right? Because they have emergency services running and all kinds of financial services. Because in America, unlike in India, they have high frequency trading. So these guys, their systems have to be like rock solid. So reliability, redundancy, build on redundancy, build on redundancy. Like you said, Erlang. Erlang is one of the things they use quite a bit. And this is built on VES, right? And so he was telling me like one of the things, the reason why they use this VES is because back in I'm talking 1970s, these guys started designing clusters, and this was the only operating system that could do it, not Unix. And another thing he was telling me is like, you could actually do a lot of hot plugging. So this is quite normal for us right now, right? But just imagine, he was telling me you can actually remove the processor with this whole thing system running and change it. And this VS thing will like do all its automatic kind of thing. And another thing is that the programs written on VS, at least for Verizon, maybe this is specific to Verizon, I don't know. It's all assembly. Right? It's incredible. So that Cutler is a solid guy. So all the people in that photo are hardcore engineers. At least, okay, Bill Gates is also a very solid programmer, we know that. But I felt kind of like very sad, you know, in between these three guys, now the power Linus is there. So, but again, but I guess it's fine because Microsoft is actually, I think somewhere in that article I read somewhere, it said that now the operating system that runs the most on Azure is Linux. It's not Windows Server. So it makes sense for them to do that.
They're actually,
I mean, they're already, I think, server side, I think Linux is already.
Yeah, Linux is totally dominant. So the thing is that Windows only runs on desktops.
Yeah.
And coming to that 400 million number, another thing is that very recently is Microsoft said that, I think it was last year's investor call, they said, we have 1 billion devices running Windows thing. But during the pandemic, they said we have 1.4 billion devices. So within a span of 3 years, where did that 400 million devices go? Right? So the thing is that basically PC usage is on a decline.
Yeah.
Right. So thankfully that horrible system called Windows is on a decline. It's not going to make it much. And what at least consumer researchers, what they are saying is that people are not buying new laptops.
Yeah.
It's a very specialized thing. It's a mobile phone which a lot of people rely. Maybe a household used to have 2 or 3 laptops. Now it's maybe 1 or 2 laptops and more mobile phone devices. So it's, and what does mobile phone run? It's mostly Linux or Linux derivatives, right? So Android. So we are on the uptick there, so we don't have to worry. Don't worry, this thing will die out eventually. That's why we have Microsoft. That's why they're warming up to Linux. Right?
Microsoft there were, I think, rumors about Microsoft trying to make their own distro.
Linux
distro.
Not the rumors, already there.
I think they're
Azure Linux. Azure Linux.
Oh, they don't have
No, they use some kind of real-time. It's based on that.
Okay.
Real-time operating system. It's derived from that. Again, it's proprietary, so we don't know internally. But a lot of people who we chit-chat to with them, they're like, yeah, we use this.
I believe they have 2, one for Azure and one which WSL is actually built on. So even when we run Ubuntu, it is not actually running Ubuntu.
Correct.
So it is having some layer in between which is running Ubuntu, which is handling the NAT and all for all of the distros.
So WSL 1 and WSL 2 are very big changes. WSL 1 was literally
kernel translation.
Yeah, it was literally translating Linux syscalls to Windows syscalls, NT syscalls. Yeah, it is the opposite of wine. We can call it the anti-wine.
I think
WSL 2 runs by it uses Hyper-V, and in Hyper-V it runs a very tiny Linux VM. So it's basically the same thing that Docker Desktop does in Windows and Mac. Runs a very lightweight Linux VM, and inside that Linux VM it uses secrets to run the other stuff. So it's basically containers.
talking about Hyper-V, virtualization technology for Linux was entirely built by Microsoft, thanks to Microsoft. Today we are enjoying containers and all that because of Microsoft.
I mean, you
2009.
We can say like, okay, we want to go to the, okay, I'm actually very, just to say this during a stream, but at the end of the day, I would say, like, for Linux to be mainstream, vendors had to actually add a lot of stuff in, otherwise that wouldn't have happened.
Actually, the Linux kernel now, I think about 90% of it, at least for the past 10 years I've been seeing, because we do the stats. I think for the past, if you look at the top contributors of Linux, the top 15 or 20, they're all people either working at Broadcom, Intel, Microsoft, Meta, Google. These are the guys, right? And so essentially it is now completely corporatized. Even when I got into kernel development, right? This was back in my first commit in 2006. I only got in because I met somebody from IBM. And IBM was in India was doing, at that time, IBM was the top contributor to the Linux kernel. They were investing like $1 billion for its development. At least this was from 2000 onward for almost a decade. But now it's led, now they're only maintaining whatever they've done. They're not actually contributing to it. So it was very difficult. So when you think of Linux kernel, we would think that, oh, this is community, I can actually contribute. You cannot anymore. Maybe certain parts of, for example, right now I can maybe do certain parts of the cryptographic modules because that is still within the community, that still works in academia. I would say 90% of the kernel is maintained by corporates.
I would say more importantly, I would be afraid of being in Phoronix the next day saying Linus fire puts a new rant about this guy literally flames him. The thing is, it's in the mailing list is public. I would be more afraid of that. I mean, let's just kind of bring the conversation back into Linux desktop specifically, because I think on the server side and even on like mobile in general, like Android is Linux at the end of the day. So Linux is already like, as the kernel, already dominant.
Server, mobile phones, everything that we use in our life now, even the real IoT devices, they're all Linux based. It's only this very small.
I think consumer hardware is where consumer stuff is the only place where Linux hasn't still this thing, except on the phone side.
When you mean consumer, what do you mean?
Like laptop, consumer laptop.
Yeah, right, that's it. That is still legacy Windows kind of.
Yeah, so I think let's just bring the conversation over there because the other place is being low in particular.
Yeah.
And that's actually where a lot of interesting problems and things which we can kind of talk.
Just before I say, we can actually see that the year of Linux is coming soon. Or
desktop Linux.
Because Microsoft has actually done something with the Xbox for a long time, because SteamOS was actually a big challenge. And recently they had actually launched, so I don't know how many, this was quite under the radar, but Microsoft is working very hard now to actually get SteamOS into Xbox into handheld.
Yeah, they announced plans to integrate Steam with Xbox.
Yeah, Xbox.
They have announced the plans. But at one point we integrate the Steam store, not
Again, so that's basically Windows, but the reason for them to actually start caring about handheld gaming market is because of Steam Deck and Linux.
No, certainly they're doing it, but the way Microsoft is doing it, right, is always with the layer of Windows. Like take WSL, it's a good example. They included it, but as a layer. So I'm pretty sure what they're going to do with the Xbox is that it's going to be their system. There's going to be a small sandbox there on which SteamOS will operate on, and install directly onto the Xbox. So it's not exactly full support for them so much as, hey guys, if you buy Microsoft products, you also get this with it. That's what's going to happen there.
They are also, I think, integrating with Epic Games and all third-party stores like EA, because that is what makes the Windows gaming ecosystem.
So, like one thing you can kind of think about is like what the Steam Deck did. At the end of the day, consoles are at the end of the day just computers with not even specialized hardware, it's mass-produced hardware.
Specialized hardware.
And now it is like the modern PS5 and the Xbox Series, whatever they call, they have a horrible naming scheme. Is basically just x86 hardware. They just have a custom-made GPU or like an APU kind of a system.
The main difference would be the system memory is
GDDR or something like that.
DDR plus
So it will be a little bit specialized like that, but nothing spectacular on the other hand. And then what game devs get is they have a reference hardware where they can kind of like really optimize the stuff. I mean, think about SteamOS at the end of the day. So SteamOS, you by default you boot into a Steam Deck kind of an experience, but at the end of the day, behind it it's just KDE. It's just Ars running KDE, right? And just a shell on top of it. Same is the case if you do like
PewDiePie actually, so like in the second video itself, PewDiePie actually makes use of his Steam Deck, which runs Ars Linux, to make it like a home lab server. So
at the end of the day, I think SteamOS is immutable, so they can unlock it. I think there's like a command you can run to unlock it.
So it's like they have
their own updater and stuff.
Yeah, so what they do is, so they have this, just like our phones, they have this AB partition system, right? So they have two root partitions. You boot into one of them, when you update or make some change. So if you make some change to the OS level, right, it makes the change on that root partition, whichever you booted into. And then if you install an update or something, it changes the other partition. And then you reboot, it goes from that, so you lose all the changes that you made on that partition. So the only change, so it's like there are two root partitions.
Okay.
Whichever you boot into, that's mounted at root.
Okay.
The other is not mounted, you cannot modify it. You can mount it and modify it if you're crazy enough, but normally you can't, right? So then, whatever change you make, like if you say, I want to maybe start an SSH server on it or run Tailscale on it or whatever, right? If I do that, that will happen to the root file system that I booted into, right? And then if I reboot it, it probably would work. But if I install an update, what happens is that it applies that update to the other boot partition, whichever is not the one I'm currently booted into, right? So after an update, if I reboot, it boots into the other partition. So now all the changes I made is gone.
What about the next update?
It's not gone. No, it's not gone as in gone. It's in the other partition. If I reboot and there's a way to get to the bootloader on Steam Deck, like you press some volume button or something, there's a way to get to the bootloader. And if you manually went into the bootloader and boot the old version, then you get the changes back. And then
if you are in the latest version and then you do another update again, it will override the other partition. So now all your changes are gone. Right? So that's how.
No. What about like the changes that we had? Like,
during the next update, it will override that.
Oh, override that. Okay.
Yeah. So it's like
making the
it just so they did that because it's really hard to break, right? It's like, say, I mean, Steam Deck is meant for users who are not well into Linux, right? So it's like whatever you do, it should not break, right? It should be stable. So whatever changes you make, however you try to break it, as long as it can install an update, it will fix itself.
Or if the update goes wrong, they can still boot from the
previous one. Yeah, exactly. Even if the update.
Grab has similar option, right? Like when we are updating, like
you can have previous comments.
In Grab, it adds a new entry. The entry comes from in your boot partition. There's an extra Grab config or extra kernel which tells you to use a different root or something. It's there. I mean, I think use the Grab in general. So Grab is there. So that's what they want to use, right? So whatever change you make, it should not be lost. The only change you get that won't be lost is the home partition, because the games get installed in the home partition. So that cannot be lost, right? During update, you cannot lose your game. So root is, I mean, the home partition is mounted read-write. You can make any changes in there, but that's about it. But
so wait, what's the situation? Like, how much memory does this occupy?
I mean, it's just running Arch. The only difference is it has two root partitions, and you boot into one with the root partition mounted read-only. Right, so you can like issue a mount command with I guess read-write flag, and it will remount it as read-write, and you can make changes to it. But again, during a next update, it will be gone. So the way I've seen a guide on I guess Tailscale's wiki. So how they have a wiki page that's with instructions on how to set up Tailscale on your Steam Deck. Right. So how they do it is by this overlay efforts. Basically, it's like you can mount. So something like bind mounting, right? So you can mount a directory on top of another directory, essentially. So now it's like you go to some directory, but you get the files from a different directory, right? So
like symlink.
No, not symlink, but yeah, I mean it's like symlink.
Yeah, this is like if you're symlink, you are basically saying like this folder refers to some other folder. But this is basically you can say that this folder is a combination of folders from two different.
Yeah, it's like you can merge two files with this overlap thing, right? So basically, how Tailscale lets you do it is like you create a systemd service file in some directory, and then bind mount it on top of the default systemd directory. So it's like when systemd looks at the service files, it sees the Tailscale one in there. So now Tailscale runs, and I guess if you update or something, I guess that's because it's not the actual root file system. It's not lost. I forgot the exact step, but that's how they do it, right? But because Steam Deck is just like a laptop that's running an AMD chip x86, you have a regular SSD, regular RAM, everything regular. You can just wipe it and install whatever OS you want on top of it, right? So you put Arch, you put NixOS, you put Barsite or whatever. Now it's like you get the same experience as the handheld, but
on a different operating
system, but you get the same experience as your laptop, right? You can do whatever you want. You can set up SSH, Tailscale, you can run your home lab, whatever on it.
Just like
if you update it, the changes won't be lost, right? It's there, just like your laptop, it's there. So I guess that's one thing, right? So now it's like you have SteamOS, but then there's like other OSs like Barsite. Barsite is basically a Fedora-based distro which gives you the same experience as SteamOS, but now it's like a different distro. You're not restricted to all the restrictions from SteamOS, right? You can basically switch to desktop and then use it for whatever you want. So I guess as now Steam Deck, since it's already being adopted by other OEMs like Lenovo and Asus or whoever, all these distros will also now it's like they'll just work by default on these hardware, right? So it's like
it's similar to what Asahi has done with Mac.
Yeah, exactly. Yeah.
So in terms of like again coming back to the Linux desktop and like switching more people to Linux, what do you think like we as a community like Kochi FOSS can like help? So Andrew is like doing like Linux installs at Vijay parties. Yeah, install parties and like Vijay's burger joint. If you guys need a burger and want to convert a user to Linux, you can like call and
we do install parties in burger installs.
Yeah. So if you have like a similar space where you could use your free time to like help someone switch over to Linux. Hopefully like some PewDiePie fans or like for some other reasons. I mean, also we could be the other reasons, like PewDiePie just decided, yeah, okay, he has influence. So those who also have like influence, like this is your time. Like anyway, the snowball has like started falling. So as much as you add to it, we'll get more traction and like more users onto Linux. So. Yeah.
For end-of-10, are they recommending any operating systems or just saying just move to Linux? What is it? What is it?
Generally, the idea is move to Linux, but they also have a few recommendations. Means, I think recommended
It is one of the best recommendations. From moving. I mean, it's just the UI. You get the Windows experience with the Windows UI. That's it. So because the start button, like you have a similar button at a similar position. But now with Windows 11, I guess since the start button mode was center, I don't know. Now would be something running wrong would be.
There is I forgot the name. There is a Linux distro that.
Exactly like Windows?
Yeah. And it is actually developed by a Microsoft engineer who actually works on Windows.
Okay, I forgot its name.
Yeah. I forgot its name as well.
It's there new too, I think. It's Linux Experiment or like Mental Outlaw. Someone has I think it's Mental Outlaw. He made a video about it.
And he actually said in his blog that his daily work is basically on Windows. He works with Windows. But when he wants to game and stuff, Windows is annoying. That's the exact word he used in the blog post.
Windows.
So he basically made a distro that looks like Windows. He made it for himself. And basically then open source his scripts and stuff.
Is it the one with both Windows and Mac OS UI that you can switch between?
No.
Not that one.
This looks very close to Windows.
No, it looks like Windows. It's like in the settings you have option to switch to Mac OS UI or Windows UI.
No.
Isn't that like default no UI?
Script like Kali undercover or something.
Instantly
switch it to Windows.
Just write no.
Yeah, I think it's right.
That's it. Like you just apply some CSS on your GTK UI and then now you have a different.
What is the name of the distro?
Windows theme over Linux.
Yeah, what is the name of the distro?
I believe Linux.
No.
Check for Mental Outlaw CPU.
That's an emulator, right?
So again, any community points to add on to that? What are the challenges that we might face to like bring more?
One more thing is Apple is actually also getting on the Linux train.
Containers,
containers, because as part of macOS 26, macOS Starhead, they are actually introducing
containers,
native container, Linux container support. So they are also in the bandwagon with this thing.
Currently for Docker, like we can use Docker Desktop, but at our company like Docker Desktop to this thing we are using Kolima.
Here is
Kolima or Rancher Desktop or
Kolima used to use Chemo before, but now they are using something called BZ, which is actually user space. User space containerization. Chemo was full kernel.
Okay, but this
this is made by Apple, right? So it's built into macOS.
Yeah, this is now.
So if I remember correctly, it just uses the Apple virtualization framework.
UTM.
Apple virtualization framework. UTM uses both Chemo and virtualization. Yes, but virtualization framework cannot emulate other architecture.
Oh, yeah. So everything has to be
then you need
but the virtualization framework is optimized. The problem on so what they are doing I checked the source code. So basically containerization, again, why are we going technically? But anyways, containerization is basically virtualization framework running very lightweight Linux kernel. I think there's a project called Kata containers, where they make very small, very lightweight Linux containers, and on top of that it's C. So basically like WSL2.
But this reason that Kolima uses, I think it can work with Rosetta to support IND60 for things.
But virtualization framework will be more optimized because Apple will do the Apple shenanigans.
Also, suggestion to convert more people. Get them into home learning.
No.
Self-hosted Flex
So yeah, that's a good way. But again, this is like a surprising take. Again, it's not a surprising take. 90% of the things that normal people do, they do it inside a browser. Yes. So this is like a deal with the devil. If you have Linux distro and they have Chrome, they won't even notice. That's a fact. So that could be something that you could do. Like install Linux means make a deal with the devil and like install Chrome on it. And like Chromebooks. It's a pain. So that's also a good way to like convert more.
Chrome OS is a fork of Gentoo.
Yeah.
For Linux.
Yeah.
But why Gentoo?
Why not Gentoo? That's the question.
I mean, it used to be Gentoo, now it's different, I think.
No, it's still Gentoo.
Why not mix? It's like
I had the same thing for SteamOS. I was like, Nix makes more sense, but everything makes more sense with Nix. So
SteamOS only gives you 2 different versions of OS.
Yes.
So it gives you every version since the beginning of time.
So I mean, this is not a flaky voice provider. We'll have another meetup for it. But like my take on a bunch of stuff is I have a bunch of problems with a lot of components of the Linux system. So like one thing with Linux desktop is it's not just one set of people or like a standard body figuring things out. We used to think there was something called free desktop. I think free desktop is a joke now. This will be a hot take, but free desktop is a joke.
Anarchy.
Anarchy doesn't. There are really good podcasts I would recommend listening to. I think Brody Robinson had a very good podcast with the creator of Hyperland, where he was actually going through that. This whole X-Wayland conversion process is screwing up a lot of people. I heard a lot of shit in Wayland is very bad in terms of accessibility. That is actually a problem. And X is also having certain X stuff. So all of these stuff are creating, like end users are not going to kind of worry about that until it's kind of that. Then one thing we had to kind of come together is try to, I mean, we can't do anything much on this. This is all up to like all of the big foundations like GNOME, KDE, all of these different projects. I'll tell you a drama which is happening in free desktop right now. So system tray. Okay, system tray is in a very funny situation because system tray is actually not a standard. And why? So, but the problem is everyone uses system tray. Discord uses system tray, Slack uses system tray, and everything. And GNOME Foundation and all of the GTK folks, so basically GNOME and Pantheon, so the elementary OS, they kind of decided, they kind of say that, oh, we have a very good design guideline and we are recommending people to not use system trays. But the problem is, at the end of the day, nobody is going to care about what GNOME thinks. People are going to build apps, people are going to use system trays. But GNOME is like, no, we are not going to want to system tray. And they are basically holding free desktop hostage. This is kind of the thing that GNOME Foundation likes to do in terms of like GNOME stuff. It's similarly very funny. There is very funny implementation details in Wayland, where in Wayland how it happens is to get a standard into the to get a protocol into the standard, you basically have to get, like, everyone should agree and some people should implement it. Now there are situations where GNOME agreed and then in the GNOME shell they actually implemented it in a non-standard way. This is something that KDE does this really well, but GNOME and all this kind of shenanigans actually create more shenanigans, which is kind of sad, especially from GNOME side. But anyways, I think a lot of similar problems like this are there to be solved in the Linux desktop. One major gripe I have, which Linus said in a DevConf in 2014, the famous one where he figured off NVIDIA, was basically like, you know, even in the kernel, like Linus has one golden rule: you never break user space. If you broke user space at one point, I mean, if you introduced a bug in user space at one point, even if it's out of the standard, now that bug is a feature. You should not break that. There was a very, very glorious email which one guy got from from Linus regarding this. But the problem is, other projects, for example, glibc sometimes does not implement standards properly, and glibc updates. And then what happens? glibc updates and things which are relying on the old glibc breaks. And that happens because glibc is like vendor dynamically link control. And then on the distro side as well, all the distros want like, you know, very small, efficient, tiny binaries and dynamic linking, so everyone links on runtime. And I will tell you exactly, as a person who develops apps for Linux, there is one guy in our team called Shreyas who is not here. He's nearby, he's not here, but I think he's watching the stream. So I will tell his pain. We have a thing, so HouseCoach has a desktop app, and in the desktop app, oh yeah, he was a beta tester. HouseCoach has a desktop app, and we want to build a dev package for it. Now here's the problem. In Debian, there are some people who are using older Debian distros and newer Debian distros, and one major thing which changed in between was OpenSSL, I think. I think it was related to OpenSSL. I think so. I'm certain for it. Now the problem, the problem related to that was, if we build the Debian package for with an old version of Ubuntu or Debian, those users can actually use it. If we build it for the new version, those users can use it. In between, we can't actually say anything. Right? The problem is, especially within enterprise settings, they might not update their distros very frequently, and that can actually mess up a lot of things. And this is actually like really frustrating. And like Linus basically said, like, hey, at the end of the day, you guys are going to. He said it in front of an entire audience of Debian developers, by the way. You guys mess things up, and you guys basically kind of do all of these things. And yeah, you guys have your ideas about linking and that sort of stuff, that makes sense. But at the end of the day, people are not going to care whether, at some point, people don't care about binary sizes. I mean, Electron is the thing. Electron is the thing. So people don't care about binary sizes, and people don't care if you like statically link to a lot of stuff. And and you know, like, and he literally kind of sort of predicted the current situation, and he literally said, basically, you know who is going to not care? He said Valve is not going to care. They are not going to give you 10 binaries to kind of function, but you guys will need to support Valve, so you will have to kind of figure out things. It will look messy, but that is the way. Otherwise, it's not going to be easy to kind of. So. There are like plans to go around. So FreeDesktop has Flatpak, and then there's AppImage. Then of course someone has to be a thing. So Canonical has Snap.
So XKCD has a comic. Like
there are 14 standards. 14 standards.
There are now 15 standards.
The horrible part is I heard Flatpaks don't work really well on Ubuntu. And snaps don't work really well on other distros. So AppImage works everywhere, but AppImages are big because AppImages link everything.
I mean, that's how it should work.
Yeah, I mean that's the
entire point.
That's the entire point. But like it's so sad. And like a lot, especially like around this packaging projects, people should really care. I have a problem with Flatpak. Flatpak's user interface is horrible, even within Mint. So in Mint, one of the things I really like Mint for is, again, and why beginners for is by default its software store thingy has support for Flatpaks. And the problem is, so a friend of mine, so he is living in Russia. That's where he's doing his studies. So he has some like networking issues sometimes with certain domains, and he was downloading a Flatpak for his ebook reader, and that ebook reader needed that Flatpak. They call it platforms or something. I think.
A separate repository.
Yeah, no, it's like a platform. It's like the foundation on top of you building Flatpaks. So it was downloading. The problem is these installers don't show the progress bar. So it just shows like an intermediate progress. And he was like, because he doesn't know, maybe he has to turn on the VPN, he has to figure out what he needs to do. But the problem is, he was not able to figure out. Then he left it for like 1 or 2 hours and then download got over. Then he kept another thing for download. The platform was downloaded there, so there was a progress bar now. Now here was a funny thing. The progress bar said like it needs to download like 1 GB of items. So the progress bar's limit is like 1 GB. He waits till 1 GB. It was a very slow download. He waits till 1 GB. And then he says like the download is not over. Now the download is going to 1.2 GB. It's literally 1.2 GB of 1 GB. Like, how is this possible? He's asking me this. 1.2 GB. It stopped at 1.5. So it's like, are our engineers, is it very difficult to find out how much things you need to download? Nix also has this problem. But generally, telling me that. I don't know. I was just telling to us flaky boys. We are not safe from here. But I think a lot of these problems, especially if you want to kind of be like a distro for everyone to use, right? It's like there's a general tendency like use terminal or use Arch, use Arch or all of this stuff. That's not going to boil down. We had to actually, when people come into it, I think at some point like we might have like free software philosophies. We want to kind of have that, but at the end of the day, for people, especially people who are not in our circles, it is not just about like the ideas. Maybe they don't really care about the ideas. They just want to get things done. And that's something that we had to, as like an enthusiast free software community, we had to kind of understand that like we should cater to them and think about for them as like their problems rather than our pushing our ideals.
Yeah. So with that I guess like we can like almost wrap up. So again, Year of the Linux Desktop is here, and it's upon all of us to make sure that 2025 is really the year of the Linux. Yeah, that's it. We'll wrap things up. Thank you guys for. So we will take a group photo.
We stand here and take a group photo.
Yeah. Okay.
I think a lot of people left.
Sit there.
No, we'll just stand all together.
That's nice. Yeah, because there's a lot of empty chairs. We just stand like this, like old fashioned and let's make two lines. Okay. Hey guys, instead of talking, let's just make two lines and we'll wrap up quickly. Go for it. Stand to the back. എല്ലാവരും അറേഞ്ച് ചെയ്യാം
കുറച്ചേരി വിടുന്നോ വാ
I can't get you guys. You have to come. What a movie says. Okay, I can see everybody. Shall I take? Yes. Sorry. Okay, this is better. I can get everyone. Wait, let me just check. Okay, guys. Here's I'm gonna take 1, 2, 3, 4, 5, 6. Done. Thank you very much. I'm the photographer always. Come on, let's go. Lunch.